Good morning to distinguished guests, esteemed faculty members, and dear participants. Welcome to the fourth day of AICTE-sponsored ATAL FDP on Artificial Intelligence-Based Energy Storage System integrated with renewable and sustainable energy sources for electric vehicles. Coming to our today's session, our chief guest for our today's session is Dr. V Sandeep from NITAP. Dr. V Sandeep received PhD from Indian Institute of Technology, Delhi in 2013. He is currently working as an assistant professor in Department of Electrical and Electronics Engineering, Associate Dean, RNC, Industrial Collaborations and MOUs at National Institute of Technology, Andhrapradesh, and past head of EEE Department of NITAP and chair of PELS IAS PES Joint Chapter IEEE Vizag Bay session. He worked as assistant professor and coordinator at School of Engineering, Central University of Karnataka from 2013 to 19. He received project grants from DSF, UGC and IEEE. He is instrumental in establishing a common research and technology development hub in renewable energy sector at NITAP campus as a project manager sponsored by Department of Scientific and Industrial Research, Ministry of Science and Technology, Government of India with a grant of 7.15 crores. He received Gandhian and Technological Innovation Award 2013, selected as amongst the top 24 innovators across the country by Economic Times Now and Times Now in 2013. He received Corporate Finalist at 3MCA Innovation Challenge 2014, selected in Top 10 Innovative Projects Award 2014 at doctoral level by Indian National Academy of Engineering. And he is a participant in Festival of Innovation at Rashtrapati Bhavan, New Delhi in 2014, finalist of IIT D Class of 18th Innovation Award 2012, silver medal for Best Research Paper by Indian Railway Board of IE in 2017. Dr. APJ Abdul Kalam National Award 2017 listed in ULE KTZ Wall of Fame with recognition as top 50 expert faculties in the field of engineering across India in 2019 and Young Faculty Award in Electrical Engineering 2020. IEEE Indian Council Outstanding Young Professional Award 2020, IE Young Engineer Award 2022 and IEEE Vizag Bay Session Outstanding Volunteer Award 2022. He organized more than 300 technical events for engineering students and mentored the winners of various competitions and hackathons. He published 40 international journals in Scopus and Web of Science and 50 international conferences and 5 book chapters and holds 2 Indian patents. He delivered more than 200 popular lectures on energy and education at reputed organizations. He successfully guided 3 PhD theses and 35 BTech and 35 MTech projects and 100 plus research interns and currently guiding 9 PhD students. He is IEEE Senior Member and IEEE Brand Ambassador. He is the mentor for few students, startups and founder of NDEEP Connect. His current research interests include microgrids, smart grids, electric vehicles, artificial intelligence and machine learning in energy systems. So now I request Dr. V Sandeep sir, please start the session.
It's part of this integrated with renewable and sustainable energy sources. Okay, so that's the reason I have chosen in the morning topic more on energy related, and afternoon session fully we will go to electric vehicle. So that way the topics also divided. Okay, and this anyway my profile read by madam. Thank you very much for this actually. So if you look at my profile, everything I planned it. Okay, I studied everything in Telugu medium up to intermediate. So no English medium and small village schools, and then I studied it. I didn't do any corporate studies and that actually. And I BTech also normal engineering colleges, but I elevated with a planning from BTech. So during BTech second year thought it itself, I decided to PhD. with the motivation of faculty. So I used to go to faculty rooms and then see that they make boards, so they're having the PhD degrees in the, so to do PhD and to receive good industry or whatever, what we should do. So that kind of mentorship, I started getting from faculty those days. Then I planned with MTech and then PhD in a systematic way and without any gap. Okay. So then that's what I made it. So BTech, MTech, PhD without any gap, I successfully completed. Then I had now almost 11 years experience in that. Okay, this is tactic. Yeah. So today's presentation, first we'll start with what is the current energy scenario, and then what is future energy demand, and what are the alternative solutions, with reference to renewable energy as well as microgrid and smart grid, how they will help. And finally, we'll discuss, what kind of energy management is required for EVs. Okay. Without energy, we cannot include this new kind of, this kind of systems or loads like EVs. Actually, that's the main reason, is it right? So now, we should have, some kind of idea whether our current grid, okay, being electrical student or faculty or engineering, we should understand that. So in the existing form or current form, whether our current grid can able to supply and support the electric vehicles or not. Okay. So now slowly it's coming in. Suddenly, suppose this year maybe some boost of something like 10 lakhs vehicles are coming into picture this year. Whether our grid can able to supply power to 10 lakhs vehicle supply, that's the question. And that way, we have a lot of challenges also. So that way we are focusing, some kind of alternative solutions like renewable energy also. So beyond renewable energy, there are technologies like microgrid and smart grid also will help you to integrate with the electric vehicles. Okay. Nowadays, many technologies going to be integrated. Is it not single technology? So that those things we'll see today. And generally expectation. Okay. So faculty, if you attend any program, so why I should attend this program? Okay. This kind of what is the benefit? I summarized it here. Okay. So one is you'll get a new content of knowledge. It's a beyond curriculum, beyond syllabus. So at least some percentage, maybe some 0.01% you will get that will be added to your mind. Is it right? So that is the answer. This is one benefit. So this knowledge will help you directly or indirectly today or tomorrow. Maybe today or sometimes maybe after 5 years. Okay, even there are some faculty and students, they used to tell us, so I have listened to your lectures, I have followed your thing, and we got benefited when I joined the job there. So that way also. So that kind of things will help you tomorrow. Even same thing for your curriculum also. You may think that one subject is there, unlike electronic, which is boring and not required for you. But that will help you when you go to job. Who knows actually? And next thing, you can also search for a lot of project areas because people, resource persons will talk about advanced and new topic from which you will take some project ideas and then you can do that also. And then you can also get new direction for your future research. Nothing but maybe faculty future research and for students projects mainly. Okay. And next is if at all I already started with projects or research work, then this kind of lectures will help to improve it. Okay. Even troubleshooting is there. People will come and interact with us, and then we will share their doubts like that. That will also help us. And next is you will also get to know the publication results because we also follow some references. Is it right? So the data, whatever we collected, whatever knowledge we are gaining here and then delivering here. So then you will also get to know same way if you want to tomorrow if you want to make a presentation somewhere, then also you need to know. So how you can make a presentation, what kind of reference you need to follow on that. Next is the most important linkage is domain experts. Is it right? So very much important. In professional journey if you want to carry, is it right? So then you should have a contacts. So like in personal life we have a family, is it right? Family members are there, friends are there. You will make some WhatsApp group, Facebook and all. But in case of professional journey, how do you make a contact? Is it right? This now today I am coming here, I become a known person. You got to know my name and then my email address, my phone number, everything. This is not doing my biodata also. Then the people, you can recognize me, I am a known person, domain expert into electrical engineering. And that's how the people also will connect. So faculty also will call me and they will have collaboration and students also. So many students after listening lectures, they used to call us. So sir, I want the internship opportunity. So next summer will come to NIT. Or I want to have some kind of, I got some GATE rank. So this is my GATE score. So can you tell me where I can get the MTech seat in IIT and can you give me some guidelines? So like that, people will contact us. So many ways. So this how you should make a linkage with the domain experts, not just simply hi bye. So that is not enough. Okay. And it's inspired by global developments, whatever happening. So that we used to get it every day. So that maybe my teachers, students, and friends. And ultimately for faculty, it's a continuous learning and experience. Is it right? So without continuous learning, teachers also will become outdated. If you become outdated, what we can teach and update our latest thing. Is it right? And finally, it's experience actually. So even now, student journey is experience and faculty also. Now once you join, everything is going to be lead with experience only. And now, particular to this, our topic in this FDP session also, talk about an AI applications in EVs actually. So I summarized here, but after this, I will start with the energy scenario. So here, AI we can use in electric vehicle wireless power transfer systems is market, and AI in energy management coordination with the energy generation and charging and storage, those things, and to improve the stability and reduce the carbon footprint. And AI can be used in ecosystem and system architecture for e-mobility. AI can be used in design and modeling optimization. AI also can be used in hybrid electric vehicles also, not only fully electric vehicle. And AI can be used automated on grid scale applications also. And AI can be used in power supply management for electric vehicles. AI can be used in car software and electronic architecture. And then another area is electric vehicle life cycle assessment and charging systems in industrial, commercial, residential. We can have categories. And then AI technology for electric vehicle scheduling and charging, discharging. And AI-based optimal planning of EV infrastructure. And AI techniques can be utilized in multi-agent system for electric vehicles. And finally, deep learning algorithm for optimal distribution system for prediction of growth of EVs. So if you look at each one is one problem statement. So even you can do one PhD. You can take one statement, you can do one PhD. So that way, so even you can take subsection, you can do multiple, BTech projects and MTech projects, you can do that actually. So this is what current trending, happening. So what is the applications of, artificial intelligence in electric vehicle? Okay, this one. And we'll elaborate. Okay, when I come to the electric vehicle discussion, we'll elaborate, so more details about how they go to this. And coming to the role of electrical engineers. So what we do primarily, we design and development new technologies. We do primarily 5 tasks. Okay, one is we generate. Yes, is it right? Once we generate, we store it and we transmit. And next is we control and convert it. But we deal with the energy and power conventionally. But actually nowadays we are also dealing with information data communication. So this interdisciplinary thing doing this. That's why people are now towards computer science. Is it right? So why these smart kids and all they are coming because of this inclusion of data, information, communication. So these are changes happened with reference to BTech electrical engineering, EEE branch. So don't think that we are only dealing with power and that. We know all electrical systems, inclusion of communication data and information is there. Even if you go to a substation also it is there. Communication is there. And if we go beyond this, any applications also, without that. I think students are doing a lot of applications of the Arduino, Raspberry Pi project. And you will introduce this data and communication. Is it right? So that's what. So nowadays every application now it's coming with inclusion of that actually. And what is the fundamental route in adding the new technologies? First thing what you should do. So you should do with what is the current status or state of art in one particular technology. So if you take any problem statement or any project, say as on today what is the latest technology as on today, for which you will search for many materials, maybe internet or literature, publications like this and all. And next is, then you will try to identify what is the problems and existing technology. Then finally, you should go with the future development scope. If everybody follow this simple 3-step model, every project of BTech students or faculty, anybody or engineer in the industry also, all the products going to be novel or innovative. Is it right? So in India also, every more than 15 lakhs graduates coming out BTech. Or then if you make each of them like 4 members or 1 pair, then almost like 6 lakhs or 7 lakhs, 5 lakhs at least. Okay, 5 lakhs minimum batches coming out. That means 5 lakhs products are coming into the market? No. That means they are not following this map. Got the point? So if you take any product, maybe BTech, any project also, then you should see this 3-step model. Then every project is innovative, not novel. Okay, that you should do. And your total BTech electrical engineering this way, even for faculty, anybody, you are electrical engineering. So we have 4, and this is the beauty of electrical engineering, triple E branch. Is it right? So no other engineering branch cannot be arranged this way. Is it right? We have a sequence connection. Okay. So generation, transmission, distribution, regulation, under which we study different subjects and different semesters and years. Is it right? So that way it happens. And now power electronics we study here, and then loads many things and here. Even EV comes at interest level. And 2 points we should observe here. So one is the smart key technologies. This is a new thing. So these smart key technologies can be implemented in any stage of power system. So this gives a lot of job opportunities for future. So that's what where the data communication and information is there along with this grid. So now that means conventional grid is converting into smart grid. Now our smartphones or whatever it is converting into smart. So same way. And next is microgrid. So the advantage of microgrid is now, so we can tap the locally available resources like solar, wind, bio, whatever it is there, and then you can generate the power and send it to direct loads. Then you can avoid this large transmission distribution rate. We have disadvantages with this actually. Okay. And then finally, so once you complete your graduation, whatever studies and faculty, if you are really perfect, then we should see that you are good at modeling, design, development, analysis, operation, control. These are the aspects. Then if you are fit for this, then you are 100% good for core engineering jobs. It is one feature. Okay, I'm good at modeling and design. I'm good at development. I'm good at analysis, operation, control. So if you are perfect at these some of the things, then you are fit for core engineering jobs in electrical sector. Okay, if you are not doing this, that means you are not meant for core engineering sector. That's it. Okay, then you are meant for other jobs. Okay. And future energy demand, if you look at every year is increasing. Okay, if you look at past compared with your past years and that, because our needs are increasing, infrastructure increasing, population increasing, is it right? So obviously our energy requirement also increasing. There is no doubt about it actually. And particularly in India also, you look at our energy requirement if you compare with 2015 and 2040 is going to be more than double when compared to any other country. Okay, so that's what actually we have that kind of demand is there in India. These are the countries having a lot of demand. We are also standing there. So to map that demand, so one solution is we should not go with conventional fuel generation. Fuel-based generation. Is it right? So thermal. Is it right? So thermal we use coal, gas, and oil. But actually earlier it was there, starting with 80% and then 70, then 60. Now it's coming down to less than 60% now. Okay, that's achieving now. So now other alternative is we should go with renewable energy. That is what we can easily address the climate change and global warming issues also. So that's why many countries, these are all countries highlighted in green color, they are seriously working towards the renewable energy production. And these are the countries are expand already 2022. We already stood in third place. So USA first, China first, USA second, and India third. This is very good to know. Is it right? So we are standing in third place in the expansion of renewable energy worldwide. Okay, that's our contribution. And in this renewable energy power generation, you should understand 2 concepts. One is you can generate the power and then connect it to the grid. Okay, you don't need to consume it. So the second category is where you can connect it to off grid, directly loads. You don't need to connect to the grid. So that is 2 waves of power generation. One is grid connected mode, another is off grid power generation mode. Okay. And 2017 itself we achieved 20%. Now we already crossed more than 42%, right? As of today. So global wide contribution is 42% we already contributed to renewable energy. So that's what it is. But China is leading. Actually, last 2 decades China is leading in this actually renewable energy. So why we are focusing on this renewable energy alternative energy sources? So 10 years ago, 2012, there is one agency, International Energy Agency. They are responsible for doing all this energy analytics and all. So even India is also non-member, they focus on India. So they come up with a scenario that with reference to 2050. Okay, if you follow with conventional patterns of the power generation in any country, so what will happen to our future generation? They come up with 3 scenarios. One is if you follow the conventional scenario, then what will happen is our global temperature will rise to 6 degrees. It's very dangerous, is it right? So every year also we feel that. So this summer is hot and lot of climate change issues, irregular rainfalls will be there, lot of things, is it right? So not only hot, the rainfalls also. And then if you switch over to alternate scenarios like second one, like a carbon capture method and then nuclear power generation, then we can mitigate to 2 degrees. But that is not a green sustainable solution. Then instead of going with, then you should go with third one, that is high renewable energy penetration using solar and bio or even other sources also. Then we can mitigate the temperature by less than 22 degrees actually. So even you can compare the scenarios also conventional and then high renewable energy penetration. We have a lot of advantage. So that's the reason many countries are following this renewable energy power generation to make it more power generation. And target is given that 50% reduction in energy related CO2s by 2050 for all the countries. So CO2 emissions we emit from different sectors, not only power. So transportation sector, agriculture sector, industrial sector, a lot of things. But we focus on here, say energy related, because we are dealing with this electrical power system. So this, yeah. So anybody can tell, and our next slide is there anyway. So what is the power generation of India? Power installed capacity. If you already looked at, that's no problem. So anybody can tell? What is the power installed in India? In terms of power is measured in watts, is it right? Kilowatts, megawatts, gigawatts. So any guess? These numbers only, please guess. Anyone? Somebody is telling. Just one or two answers you please tell. I said yes or no. And then we'll move to the slide. Any guess? Say the numbers, any numbers in terms of megawatt or gigawatts. Sorry? 210? 210 megawatts. Okay, no, very less. That is even less than one power plant, this thing. I think it's less than your Vijayawada power plants. Yeah, then that's one. Then 726 megawatt, no less.
10,000 megawatt.
15? 1550. No. Then 50 or 1250, no. 1260, no. Okay. So even one power plant, if you visit thermal power plant, even if this VTPS is there, so that itself I think 2000, I think 2000 plus. One power plant in this Vijayawada 2000 megawatt. Even we have other Simhadri, CSM, many are there. Then
15,000.
50,000, no less. That is also less. 50,000 even that is a capacity. Andhrapradesh capacity is more than that. I am asking country. 4,50,000 megawatt. That means 450 gigawatt. 4,50,000. Okay. And out of which you can look at renewable energy. So 1,50,000 we already derived from the grant order. That means what is the percentage? 1,50,000 divided by 450. That means we achieved 33%, one third. So 33% of the power in India as on today is generated from renewable energy. And we have a target to reach that by 2030, even before that. So we will reach 50%. So in India, 50% of energy is going to be generated through renewable energy only by 2030. Even before that, it will happen. Okay. So that was slowly this coal-based power generation will come down. Even also government has taken decision to shut down the coal-based power plants. All thermal plants will shut down from mostly 2035, 2036 and we have many schemes that we should close that even conventional vehicles and then these kind of things from 2047 by celebrating of 100th Independence Day. Like many things like that. We lose a lot of things. They have to shift the job to other sector. So those things will happen. Okay. Next is surprisingly, you should see who is generating the power. Okay, that India. The central government 23%, private government 53%, and then state government 24%. If you look at every month or every 6 months or whatever year, the private share will increase. Okay, even I am observing last 10-15 years actually. It's coming with 10%, it's slowly increasing. And the government share will reduce. In going, that's what privatization is going to happen in power sector also. So government will not establish more companies, most probably. But private agencies are more interested actually. So that's why you will have more opposition with private also. And this is what the cumulative of different sources, okay, in renewable energy. We have wind power is there, solar is there, small hydro, biomass, waste to power and all. And highest now we 89,000, close to 90,000. We have target by 2025 1 lakh megawatt we need to install to solar actually. That's the target is given. So already we are achieving it. So wind power we have potential we have 50,000 potential is there. So whereas we already achieved 47,000. So total 1,52,000 we achieved by August. So this August 2024. So that was our achievement actually. And this 1 lakh megawatt of renewable we achieved in 2021 actually. We already actually. And if you want to have any data, this portal is there, NPT. So National Power Portal. So I want to download the data. If you want somebody wanted to do some data analytics projects on energy or something like data science related, machine learning, artificial intelligence. If you want data, is it right? So those data you can get this kind of portals. It's a government portal is available, right? Okay, earlier it was not there previously. So recently, I think 7-8 years ago they are maintaining this. So this is one portal we have, and also another portal CEA. So Central Electricity Authority. So there also you get a lot of data also available. So you get a dashboard like this. You want data about generation, you want data about transmission like this or that. So you get an Excel sheet. It's open source. You can download them and use them. So that's way it is. And coming to grid, yeah. So we have this Power Grid Corporation of India is there. So this is the only major transmission company which owns interstate and all. So we have 5 regions: so northern, eastern, western, southern, and then northeast. Except the southern. So other 4 regions were interlinked actually. So then we made a linkage with central to southern grid. So that is how we have. So this part here. So we have different regions. Is it right? So these all different regions will link with HVDC links. Okay. So primarily what will happen is each region will have different frequencies. Okay, one may be 50.01, another is 50.03, but you cannot synchronize them. So to synchronize the grids, you should have the same frequency. Is it right? Then what you should do? So you can convert that in AC to DC. Again, that DC will be given to other region. Then it will be converted to AC. So using HVDC, it's a very popular technology. So now that's how it is made. Now India is planning that we have one nation, one frequency. Even if you go to the portal also, one nation, one frequency that we are planning due to this interconnection. So this we achieved this 2013 itself 10 years ago, one nation, one grid, one frequency by linking all the regions actually. So that we are planning now. And we have National Load Dispatch Center is there, under which regional load dispatch centers and then state load dispatch center. So through that actually power will be distributed. Okay, these load dispatch centers will they will buy the power, they will sell the power also. Okay, we can also borrow power from Telangana, Tamil Nadu, even Maharashtra also. So that's not possible actually. So these load dispatch centers will be possible. Even electrical engineers, you have a lot of job roles, even internships also. They provide internships, even project work, BTech final year project work, and then jobs also. So, but they take through the GATE exam actually. And these are the headquarters. 5 road dispatch center. We have several in Bangalore actually. And this is the transmission network. So this map will tell you only 400 kV, not small lines, high power line, high voltage line, 400 kV above line. And after distribution side we see this. Okay, right? So this is what we get. But still we get awards. So, but what will happen is, I'm not taking negative. Because of our infrastructure, what will happen is we are getting high transmission distribution losses. Okay, in India, if you look at once in it was 33%. Right now we are coming 20. So you look at this 14, 15, 20. Still now this year, 2024 also we have 20% down. That means you are generating 100 megawatt at the power station. If you are reaching utilization, you are losing 20 megawatt. Still it is happening. So this is the biggest drawback of renewable process. Transmission distribution losses. That is like evergreen challenge for electrical engineers. So now these people are now finding what is the smart grid technology, how it will help to reduce the transmission distribution losses. That's one. Apart from that, you completely avoid the transmission distribution loss things. Then you go with the decentralized power generation using So I mean solar and wind. These are drawing power from the grid. You install solar power plant in your college itself, then you consume it. Is it right? Then you will not yield to transmission distribution losses. So that way, now decentralized power generation is emphasized now. And you look at the old average transmission distribution itself 8%, whereas India is recording nearly 20%. And all the countries having less than 50 now. Okay, that means we should comment on what kind of an energy efficient or advanced technology that we are using in India. Okay, this way where electrical engineers roles are there. Okay, in this. Okay. And our per capita consumption also as of today, so 1350. So 1350 kilowatt of energy we are consuming. 1 person in India, so 1350. Okay, the units are consuming. I think you know the units, is it right? For your electricity bill, homes also get units. 1 unit equal to 1 kilowatt hour. So that means per person we are consuming 1350 units we are consuming per person. And also we are electrified the villages also. End of the growth plan by 2070. We have 6 lakh villages already. This is also very late. We got independence in 47, 1947, but we very late we are electrified. And our peak demand is increasing. Is it right? So every year is increasing. And then energy requirement also, million units also increasing. Okay. And you can look at the power generation also. Every year, coal is going to be come down, and more power generation will happen with renewable energy. This is worldwide data, and you can see the declining power generation using coal. It's slowly coming down, and rising. You can see the rise in power, wind and solar. Okay, this is what happening every day. And I already said, so what is the global contribution to renewable? It's nearly now as of today 42%. So 42% of power we are already generating from renewable energy global. Whereas in India, how much? I said? From India, how much? How much percentage? I already said, How much percent we are generating? No, 21 now. I said 1,50,000 megawatt out of that is 4,50,000. 33%. 33% 1 by 1,000. Is it right? Yeah. But whereas global 42%. And so there are some countries they are claiming 100% power generation. Even if you go to Canada and some South America and then African countries, they are 100% generating using this renewable energy. Okay, they have that confident access. They are climbing that access. India, we are banned of that 30 to 40 plan. Okay, so this is what competition is coming with this alternative generation plan. And I was talking about this power per capita consumption per person. And if you look at this, developed countries like Canada, United States, and other Western countries, we are consuming 1/10 of their consumption. Okay, there they are consuming 1,300, 16,000, 15,000 like that. That means we are consuming 1 by 10. Is it right? So 1350, whereas there are 13,000 plus. That means 1 by 10. We are consuming less when compared to Western countries. But what will happen is, can you guess these two are the highest carbon emitting countries in the world? Any 5? Can you guess countries' names? Huh? Tell the names, the countries' names, Huh? China. Yes, USA. USA, who said? Somebody said, huh? You said. Okay, USA. USA. Okay. Huh? India. Pakistan. Okay. So yes, we said right about other people. So China is first, USA, and then India, Russia, Japan. Now we should talk about these two countries, India and Japan. Is it right? So our consumption is 1 by 10th of the developed countries. Still we are in the polluted countries. Then they should think about it. Is it right? Why we are in this place? We are consuming 1 by 10th when compared to Western countries. But still we are in carbon emitting countries. Japan, very small countries. Okay? But still they are contributing. That means we should think about what kind of technology that we are using it. So that's what we have to reinvent them actually. And the greenhouse gas emissions also, if you look at last 3 decades, is somewhat we are trying to mitigate them. But the problem is in China, whereas all countries including India and USA, they are trying to mitigate coming down our emissions. But China, they are going to touch the sky. So that is a problem. So they are not only contributing those negative things for their own country to the global also. Then who will control them? That's not in an individual hand. Is it right? So I think there are some global platforms are there. But they should listen, So that's the problem actually. And we should bring some of these sustainable technologies in not only electrical sector, other sectors are like industry, transportation, building. So that's where we are bringing this EV in transportation sector, then we should contribute to EV. Whereas industry, we should come with some zero emission materials and all. Whereas power generation, we should completely depend on renewable energy. And building, we should come with some kind of a smart buildings technologies. So this way, every sector should contribute to mitigate that kind of CO2 emissions or greenhouse gas emissions actually. And we have this is a classification. Is it right? Well known. Power generation, renewable energy. So wind energy, solar, bio, small hydro, geothermal, and wave. So these first 4 we are successful in India, but geothermal we have not exercised in India. Wave and tidal we have done through pilot projects. Right in Madras, right in Bombay, they have done it actually. But we don't have any plans actually. And also you should see other applications of renewable. It's not only meant for power generation, it's also other applications. Sometimes you have direct application, indirect application. Then we can use for cooking, we can use for heating, we can use for water pumping, transportation, building. So like that you have many other applications. Okay, don't think that renewable energy only meant for power generation. So sometimes if you want to heat the water, then if you use electricity to heat the water, that is inefficient method. So rather than you should go with solar thermal, that is more energy efficient actually. So that's why you should think about direct and indirect applications of any energy source actually. And can you guess actually, this is a solar potential. Can you guess what is the energy that we can generate from Indian potential? How much solar energy we can generate per day? Can you guess? Per day, how much kilowatt of energy? Kilowatt hour. The energy is measured in kilowatt hour or units. How many units can be generated? That too specific to a space, is it right? Okay, maybe meter square. Okay, per meter square per day. Okay, meter square means maybe this style is more than that. Maybe this is 1 meter. Okay, this is 1 meter more or less here, and then up to here. Okay, so 1 meter square. Maybe you assume that this one tile. From this one tile, so how much of solar energy can be generated per day, as per Indian conditions, an average. Any guess? How many units, how many kilowatt hour? Any numbers? Tell me. Alright. Anyone? Huh? 1.5 is less. The other number, I said less, then you should increase the value. That's it. You don't want to try. 2.8. 1.8 less. Is less. Yeah, 5. 5 is correct answer. So, that's the minimum actually. 5 kilowatt, 5 units. So 5 units you can generate per meter square per day that we can generate. Even then the MNRI, Ministry of Renewable, they claim that 7 also can be generated, but that's specific to some areas. Maybe that is Jaipur, Rajasthan, these areas actually. Okay. But average we can generate easily 5 kilowatt hour, 5 units per meter square per day that we can generate. So that's what our potential actually. And we have solar plants also. Many innovations are coming, floating solar plants. Is it right? Even you can see nearby is for us, Ramguna, Telangana, NTPC plant. So we have one floating, solar power plant is there. And we have technologies are there. So I think you are aware of solar cell. It will be converted into module and then it will connect to it. And finally, panels will be available maybe 200 plus wattage and different technologies are coming up here. And we have this solar energy. I mean, how the conversion will happen. Okay. So this, you are aware of this energy conversion process? Yes or no? Yes. Okay. So now here we can get the solar now, and now that will convert the energy due to this PV effect, and then you have a DC will get it from solar panel. Then you use MPPT algorithm. So here what is the challenge is we need to extract the maximum power from the sun. So then we will apply the algorithm, and then ultimately your loads are there. I mean grid will be in terms of AC. Whereas generated power from the solar is DC, then we will convert the AC to DC to AC using inverter. Okay. And also you can store the energy in the battery because you have a DC here. So you can store the battery to charge control. Charge control converter will be there. So which will store and the charging and discharge will happen to this DC converter, which is bidirectional. Right? And also we can try to track the cell and then degrade it. So in this there are two mechanical structures will be available. One is single axis tracking, another is dual axis tracking. So that is available to us. And this is solar power characteristic. You can draw the voltage versus power. For different solar irradiations, you will get a different flux. Then our challenge is, irrespective of the solar irradiation, you should track the maximum power. So for this curve, this is the maximum power. For this curve, this is the maximum point, this is maximum point, this is maximum. That means we need to operate your solar system at the maximum point so that you will get a maximum power. Otherwise, if you are operating here, that means your efficiency of the complete system is less. Okay, that you should not do that. And then you can operate them in 4 ways. You can make the configuration. One is grid connected PV system without battery, with battery. Do that. Another is standalone or off grid with battery, without battery. Okay, 4 ways is possible. Okay. And this is what the structure generally you see that actually. So solar and DC inverter. So this side we use MPPT to extract the maximum of solar, and this side inverter control. So ultimately here we want a fixed voltage and fixed current. Fixed frequency. Is it right? So in case of single phase 58, 3 phase of 58, but voltage is 230 for single phase, and then 3 phase 450 and 400 hours. Okay? That we need to get a fixed voltage and fixed frequency. This that will be done by this inverter. That we have to ensure that. And we can connect like this. Okay? We have solar panel strings or arrangement. We have a inverter which will be there. And this is one module and this is another one. And directly we can connect to this. So these two are two systems and then connected to inverter. Whereas second one you can bring this DC converter here. That means sometimes this voltage is not, we cannot boost the same voltage in the AC. Then we have to carry this DC converter. So that is required here. This is the second one. And this how we can make modular arrangement. Okay, suppose in one college you have a 500 megawatt plant is there. Then you can introduce another 200 megawatt plant. This is second model. So like the people, this how we make a modular thing and then connect it to the system. So this is possible. And we can establish single phase, single stage PV system. Okay, so what is a single stage mean? So we have one conversion, DC to AC, one stage, one conversion. And single phase, output is single phase. That's it. Okay, so we have a PV system, we have inverter, and we have a filters are there. Okay, and we have a single phase transformer connected in here. And you can make a multi-stage loss in single phase. In power quality problems are there with reference to output in previous one. Then what you do is after the inverter you use isolation transformer, and then this AC will convert to rectifier again DC. This DC will be converted again AC. So 3 times. But power quality is improved when compared, but cost is more when compared to previous. Is it right? So this is another technology. And 3 phase. If it has your demand in terms of connected to grid or load, your 3 phase, then you should use 3 phase inverter rather than single. Is it right? So then you have 3 phase inverter, filters, transformer, and then connected. And one can make this different model kind of. This is one system, this second system. both are isolated, and then you have one common inverter. Okay, instead of going with this one inverter, second inverter, both are operating parallelly. We can have one common inverter. That is also possible. And this is a control strategy, simple. One can understand easily. To give this maximum power point strategy, so sense the voltage and current from the PV panel, and at the same time sense the DC link voltage. And based on that, you can apply the algorithm for this PLM generator, give the pulses to MOSFETs or LGBT, which is their DC converter. And for which you will sense the voltage current from the grid, output voltage, and you have a reference from the DC. So then you will have a actual voltage and reference voltage, you will generate the error. So that error will be given to PA controller. So PA controller accordingly will be given to control current control. Thereby you can generate video pulses for this MOSFET LGBT, which is there in the inverter actually. That is it. This is rooftop technology. This is what we see in the houses. Every house. They have solar panel, charge controller. You can charge your battery. That's one thing. And next is you have bidirectional inverter is there, and loads are there, utility is there. Suppose loads will be energized from battery. So from this load it will take inverter will charge your loads. And if the battery is not available, then directly grid can supply the power to the loads. That's the second. And battery can be charged from grid also, not only from the solar. This grid will get the power from this and then charge it. This is all. Even battery power also can be pumped to grid also. So this way many combinations are possible. This is what normally what we establish in houses. And this is a bigger system, which is connected substation. So 33 bars, 33, 66, 110 kV substation. This is how we have the these are the net metering system. Definitely you should have net metering system. So through net metering system, how much power you are pumping to the grid. So the meter will measure it. That will be detected minus in the electricity bill. So maybe you have current bill is maybe 1000 units are consumed. Whereas through solar you have generated maybe 300 units. Then there will be 1000 minus 300. Remaining 700 units only you have to pay money. So that way the net metering system will work actually. And double metering also possible here. And this is a total typical solar system actually. We have a lot of control functions we need to do that here actually. So one is voltage control, current control, DC link voltage. So if you don't maintain DC link voltage, output also will vary. That's problem. And if you want to synchronize with it, that you need to take care. So other things also conditioning, monitoring and control with reference to grid support, product things also we need to take care of it. So this is the overall actually. So this each one is one problem statement actually. Your objective. So what is my objective is only dealing with current control, voltage control. So like that. And beyond solar, I mean it's not only power generation as said, it can be used for some kind of other application like transportation. Okay. Now people are talking about solar EV. But actually, this is again one challenging actually. Your traction motor rating is much higher. In case of car, you take it, so easily that will be 20 kilowatt and more than that will be having. Okay. Even your bike also will have more than 3 kilowatt. But whether you have solar panels of that many kilowatt to keep it on top of the vehicle or something, isn't it? Or how much time you will park the vehicle to charge it fully your battery and then run your vehicle. So these are the challenges. But solar can be some auxiliary kind of power supply for a vehicle that is acceptable. And you can make solar hybrid. So what is hybrid here? You can connect one is conventional grid connection. You can get a charging to battery, that converter. And you can use ultra capacitor for dynamic conditions also. This second. So by introducing these two, then it become a hybrid EV actually. That's possible. And solar total autonomous vehicles, underwater vehicles, solar boat. Okay. And solar rechargeable aircraft. Okay, even including NASA also they successfully debated pilots also. So we have two propellers, each will have its own drive. One master controller, this one solar array this side, and another solar array this side, left and right side. This is also possible. So this kind of solar array plans. Okay. And two redundant inverters will be there, even one phase, other will work. And both inverters can even more than rated, it can supply power to the motor also. That is also possible here. And coming to another wind also is going well, so very well. But only thing, the cost of onshore is coming down, land based actually, but offshore is not coming down. That's a problem actually. And this is wind potential. And this is a wind map of India. Okay, if you look at strategic locations that so this violet and red, we have very good potential in these areas. Okay. It's already government identified. And we have 50,000 megawatt of potential we have on land-based actually. And a few years ago already we have exercised offshore wind power plants in coastal corridor of Gujarat. So we have this curve for the Gujarat state now. So in this curve they tried to establish this offshore power plant in the sea. Is it right? So that kind of plant. It will come in future also. And this was the cumulative power at a different state. So combined state of Andhra Telangana we have 5,300 potential, whereas Gujarat is having high, 10,000 megawatt they have. So already they have installed fully. And right now as of today we achieved 47,000 plus. Already we achieved. Now India has to focus on offshore wind power plants in the sea. And these are the strategic locations. Combined state of Andhra Telangana. So these are locations. Normally we will find in this is Andhrapradesh district. Very popular for wind power generation. Even solar also they will have it. So a lot of opportunities. Even near to us there is nothing but one place in Renewable actually. So that is this one place. And then this Tirumala Tirupati is one. And Kadapa near one place. And this is Hyderabad. I think if you go to Hyderabad, this Cheval. Renewable district Cheval depends on good power plants. And here the conversion loop you should understand wind power, and you have a rotor will be there, gearbox will be there, generator. So that means you have kinetic energy will be converted to mechanical energy will convert it to electrical. Electrical energy will suitably supply to loads and grids. So that way it is there. And whatever this arrangement completely will be on top of the wind turbine. Okay, I think you see the wind turbines so on the top. So that's called the part called an neckling. So all the arrangements, you have a turbine, rotor blades, rotor, and gearbox, and generator, controller, everything on top of the wind turbine. Okay, it won't be ground floor or something. So you have a tower on top. This neckling will be there. This neckling you have all the arrangements actually. And as of today, actually one can generate, so almost like a 15 megawatt power. One wind turbine can generate 15 megawatt power. Okay, so that's our achievement actually as of today. And we have different generators. We don't have options in solar, but solar we have technologies are there, solar cell technologies actually. But here we have technologies related to electric generator. We have signal generator, spiral cage, W-fed, permanent magnet generator. Now trending is going with permanent magnet generators. Okay, more efficient when compared to previous one. If you want other suitabilities, W-fed also better actually. And like solar, here also we need to extract the maximum power. So irrespective of the wind speed, we have to track this maximum speed and operate our converter to extract the maximum power from the wind turbine. So this is also challenging here. And this is a configuration. We have wind turbine, gearbox, generator. In case of induction generator, it will use capacitor bank for cell-based generation and then connect to the grids through power bypass. And this arrangement will be there. So there are two types here. So this is a full scale. So what is meant by full scale back to back? Suppose you have a wind turbine is meant for 5 megawatt. Then your generator should be 5 megawatt. Is that right? It should not be less than that. And that means these converters also should have capability to carry 5 megawatt power. That part full scale. And then back to back. So these are back to back connected. And similarly, you can previous one. So this is a W-fed. So the advantage of W-fed is not to be full scale because rotor power is less. Your slip also is less. Is it right? Slip is less in there. Is it right? Now you can use a low rated power. So only 30% of the power will flow through this rotor. Then you can have these less rated power electron converters. Then you can use them. This is the cost effective. So this can be meant for large power generation. And this is synchronous generator. This W-fed synchronous generator with back to back. And like this you can make distributed. We have one power plants. And this is now we have these distributed means here we have DC link is there, AC DC, DC to AC. Now you can have a battery. Okay, through charge converter, DC converter. So like that you can introduce different plants and these are distributed energy storage system actually. But whereas you can keep centralized. Instead of keeping the storage devices for each wind power plant, you can have one centralized. But one can compare it. Okay, technical, you can take a project. So previous version, this version. The distributed energy storage is better, or centralized storage is better for wind power. Now if this is a problem statement, you can make a comparison and you can submit a project. So like this. And similarly, this is a W-fit also. And full scale, this or we can connect to AC grid, combine them. Also, wind power plants can be used for HVDC also. So whatever now you get the AC, that AC you can convert the AC to DC, then connect to other region of the DC. Okay, one region to another region. So these wind farms also can be used to interlink between the regions. Okay, southern region into central grid or something like that. And one technology is coming up well now, that is solid state power transformer, that is nothing but power electronic transformer. So here we can avoid this conventional based transformers, you can come up with power electronic transformer. This is one technology is coming up. And final conclusion you can see, if you have high speed generators, then if you have multi-stage gearbox. Now in this gearbox also earlier mechanical are there. Now it is electromechanical gearbox also is coming up well now with electronics. Now you have options like 1:3, 1:5 like that will be there. So that's what meant for high speed. And then medium speed generators, one stage gearbox, one ratio will be helping. And here low speed. So whatever you see in the rooftop of the buildings, apartments or houses, so those wind plants now will not have any gearbox. Here you will get variable speed, you will get a variable power or variable voltage. But you have through power electronics, you will convert them to DC. You have battery. Again, that battery power that will convert it to AC using inverter. Okay, so here we don't need to have any kind of gearboxes now. Okay, and of course you can avoid this multiple conversion. One can work on directly AC to DC. So variable voltage, variable frequency can be converted to fixed voltage, fixed frequency using AC to AC matrix converters. That is also possible. We can eliminate directly DC component. That is also possible. And like solar, here also you can make complete configuration there. So what are the technologies required to configure the system is better. So in terms of control function, some specific function, monitoring and control, so like this. And these are offshore. So now we are adjusting this potential of land-based wind power plant. Now we are moving it offshore. So in India now next decade, every future also, they are starting with coastal corridor for Gujarat. So then even India, Andhra also you might see in the next after 10 years. So this kind of plants will come. But it's a huge expensive. Okay, so huge expensive when compared to land. So that's a problem. And now any technology power electronic based to implement power electronics is important. Is it right? Because we are not getting directly fixed voltage or fixed frequency or constant power or something like that. Everything is variable from the source side. Then we use power electronics. Is it right? So to connect with the grid and load. So power electronics is going well in terms of two development things. One is in terms of power electronics switches development. Now people are moving to silicon carbide and gallium nitride switches. And we know up to IGBT. We know the diodes. Is it right? Thyristors. Then GTOs, gate turn-off thyristors. Is it right? Then MOSFETs, IGBT. That's what we know. But now people are moving to silicon carbide and gallium nitride, which have wide band gap devices. Right? So that advantage is going now. So now we can see the power electronic application everywhere. Okay. If you take a core area of power electronics for your study, I think you have plenty of opportunities in many industries. Okay, you can look at them like automotive sector and transport sector, and the consumer side, and then utility side, defense and aerospace and industries. Everywhere power electronics is there. So without power electronics, you cannot imagine this now. Even this mic, okay, my laptop, my system, anything. Is it right? So without power electronics, there is no device nowadays actually. So you use that. So that way you will have plenty of opportunities in many industries. And we use them everywhere. Transmission, distribution, renewable energy, transportation, energy storage, drives, home appliances, aircraft, space, telecommunication, computers, everywhere you use power electronics. That way if you take it, power electronics your hot area, favorite area, and do the projects on based on that, you have multiple opportunities in industry. Okay? And for which you have complete equals. That's why you study power electronics mostly in all engineering and third year. Is it right? So we have prerequisites up to second year and then you will go to power electronics. So this is what I was talking about, semiconductor devices evolution. And right now we are moving to, even though that those inventions happened in 2008 and 2010, now we are moving to those segments nowadays. These are the trending research is happening for electronics. One can work directly power quality, because ultimately at the end, user side, whether you connect it to loads or grid, power quality is very much important. Is it right? So here also now fan is running constant, so that means it's getting constant voltage. If the voltage is very means that means power quality issue. Sometimes you see the effects, is it right? Sometimes in power system also you talk about stacks, different things. So harmonics also. So those things we can eliminate with the devices and without devices, without any expense. So that's the one solution. So another is a complexity reduction. Always people will propose one system, but there is other person will come, they will make a very smaller size. Okay, maybe in terms of size, reducing the number of components in the system. Maybe you see the systems also, desktop system, old days it was a large size. In TVs also. Now TVs also is coming just glass, is it right? So technology is growing now. So like that you can reduce the complexity always using power like that, there is one chance. And then always you have a chance to improve the efficiency, reduce losses. Is it right? So nobody cannot reach 100%, any system. That means that will become, if it is 100%, that will be ideal. Ideal case is not at all better. Even if you look at transformer, what is the transformer typical efficiency? Transformer typical efficiency. I think you already did it now. Second day. Efficiency is highest is 100. Ideal. Then tell me. No? Any answer, please? Tell me any number, efficiency. 69. No. Then it's very poor.
Transformer efficiency 95%.
Anyone? 80, no, little less. 80 or less. 99. 89 less. 90? You said? Somebody is saying 90 something? 95. 95 is correct. So typical efficiency is 95 for transformer. Whereas you look at the induction motors and all, that is 80, 85. Okay, if you look at permanent magnet machines, it's more than 90. Okay. And now we can use multi-port converters. This is also interesting. Okay, whereas the input side and output side you have multiple stages. Okay, so then you can tap them and use them also. And then hybrid and parallel. Maybe you bring some, for example, solar and wind is there. You can have parallel operation. Solar power plant is there, wind power plant is there. So both you can have a parallel operation. That you can do that. And then operation and dynamic conditions and all. People will do mostly with static conditions, but you can explore for dynamic conditions. Suddenly you can change the load, or you can bring some new things, and then see what is the performance of the system. And then you can try with silicon carbide, gallium nitride, and then novel algorithms and hybrid algorithms. Now people are talking about this, cyber-enabled power electron. Nowadays, any equipment can be connected to cyber. So I'm going to detail today's lecture also. So that means in physical, so in electrical, every equipment is physical. Either starting with the motors, generators, transformers, circuit breaker, relays, whatever it is. So all the devices can be connected to cyber. This is what now interdisciplinary. So industries are working now. They are not making any conventional materials or devices. They are coming. Now if you buy anything else, people will ask you. Even if you buy two-wheeler also, will ask you whether a Bluetooth connection is there, whether a human interface system is there. People are expecting that for user friendly. So similarly, this power electronics also, whatever power devices also, in future it is coming with cyber enabled everything. Okay. Now for the extension, you please let me know when is the way. Well, then close break then after I should continue. That means I should finish by 12 this. Now they will better than late now. So, you want break or not? Sir, if you take give you 5 minutes break, can I continue another 1 hour? Huh? No. Okay. Should I continue now and then finish it? This is what we do every day. Then there will be one. Okay, then we'll continue. We'll continue and then quickly finish it this morning. Yeah. So now, extension to this, till now we discussed about individual sources, solar and wind. Okay. Now what we do is, we'll go to extension of this connected with different sources here. So what we do is here, we'll connect the sources, combine them. Okay, we'll combine here in the solar and wind. Now we can form a microgrid. So that means where you have different distribution sources, solar and wind, bio, all these things you can combine them and then connect it to grid. That's possible here. We have definitions also. And ultimately this microgrid we can make 3 forms. One is AC grid, DC grid, and hybrid. That means ultimate output is AC. Whatever sources you connect them, so my output is AC, ultimate output of the system. Second one is DC. That means your load should be DC. So what are the loads DC? Any examples? DC loads. DC loads. No idea. DC loads. Huh? Yeah, batteries, EV batteries. It's only. Is it? And then next other one, last one is a hybrid, where you have both combination AC and DC. Output both, all two will be there based on this you can do. So this is one example how it will be working here. Now with regard to conventional system, we have a conventional grid. So you have circuit breaker, we have 3 feeders, feeder A, feeder B, feeder C. We have 3 feeders here. We can see that in the first feeder, we have generating sources. Maybe this is solar, this is wind, and this is storage. And each source it has its own controller. Okay, its own microcontroller, micro source controller. And we have loads, whatever arrows that is indicating arrows, loads, etc. And now you look at observations feeder B. In feeder B there is no generating source. That means it should get a power from the grid only. Or if you draw the power from the feeder A, feeder B, that is also possible here. And feeder C also similar arrangement is there, one centralized control is there. Now you can operate this complete microgrid with isolation from grid by operating this CP4. Circuit breaker 4 you can operate, and then we operate this complete microgrid off grid mode. If you want to connect with the grid, then you connect with the grid actually. So this is arrangement you can do. This AC microgrid. And then you can connect with the different loads here. So you have the solar, wind is there, suitably you can have power electronics, and finally AC was bar. Connected to grids and connected to grid or connected to loads. So this is AC. So that means ultimately this output is in terms of AC only, not DC. We are not generating any DC. Of course we are getting DC here, but we are not doing that. And in case of DC microgrid, but problem with the DC, what happens is all the DC equipment and devices not having same voltages or same current. Is it right? Even mobile phone, computers, laptops, and printers, each DC devices, they have different voltages characteristics. Then what you do is, you have different irrespective of the sources. You can convert it to one common DC, from which you can categorize the high voltage DC bus bar. Then these are high voltage applications. These are medium voltage, medium voltage applications, and then low voltage consumable loads and all. So that way you can control it. So advantage and disadvantage of this thing is each DC load required one DC converter. So that's a disadvantage here. And you can combine them also, AC and DC. We have AC DC bus bar connected to power electron DC load. So another is you have inverter, through inverter connected to loads. So this system having both AC and then DC also. You can operate them AC both grid connected and primarily we do these functions, active and reactive power control, voltage. These are whatever we do in conventional power system, we have to do it here also. That is the thing. So this is a typical one case study. So let us assume that we have solar and wind, we have one sunrise controller, we have loads of category, and we have batteries there, and emergency supply systems like a diesel and other field-based systems are there. So this is a system. And to start with this kind of things, first is, we should do with, what is the sources available to you. So whether it's solar, wind, hydro, diesel and CHP, combined heat power plant. So these are the sources modeling. So you should understand. Is it right? Suppose I will tell you that, your house is there, so solar is required. Maybe your parents are thinking that, solar I want to install. Then you should tell me, that how much kilowatt we need to install. Can you install 1 megawatt in our plant, in our house? Then, so how much of solar is available? Is it like, what is your energy requirement like this? And then next is energy storage requirements. So what are the different energy storage elements are there? Battery, 5 supercapacitor, fuel cell, any pumped storage systems and all. So you can classify them according to your structure, whatever need. Then you can choose them which sources are primarily important to your this campus or house. Next is which battery storage I need to select them based on this model. Then you can classify the loads also residential, commercial, industrial and all. And then identify load measurement based, component based. One can do control and uncontrolled. Some of the loads are uncontrolled. Okay. Maybe sometimes you want to operate this fan at single speed, then it's uncontrolled, not required. Sometimes you want to variable speed, maybe industry, some processing and all. Then you have control things are required. And we have 3 levels of control. And communication technologies also we fully depend on with different technologies, GSM, GPRS, 4G, 4G, and then PLC, different technologies we use them actually. This is structure of microgrid, energy management. So in energy management, nothing but simple. You should create an energy balance. So what is energy balance? You have whatever generated, it should be equal to demand. You should consume it. Then energy is balanced. If it is not balanced, suppose energy generation is more, then what you should do? Generation is more than load. What do you do? Generation is more than load. Tell me. Generation is greater than load. What should you do? Energy balance is not happening. You should do something, energy is losing, What you should do? Yes? Huh? Yes, good. Correct answer. We should store the energy. Excess power, we should store the energy. Then other option? Dissipate. To dissipate means okay. Yeah, something you will dissipate, residue something. There will be residue branch you can create and then dissipate in the heat, that will go waste. Okay, yeah. But if it is small amount, you can do it. If it is large amount, any other method which is more economical benefit to you? One is storage, that's good, economical, you are using again back, but dissipate the waste. Okay, you should not recommend that. Next, excess energy is there, generated more is there, load is less. Then, tell me. Various steps, yes. Yeah. Huh? Right. Yeah, that is what you are doing, alternate usage. Okay, how the energy is happening. But another simple one is you can directly give it a grid, If you can feed the power to the grid or sell the power to the grid, pump the power to the grid. Even solar also, if you install solar in our house, you consume it, whatever excess energy is, you feed into grid only. That's one option. And second category, where you have load is more, generation is less, then what you do? To create energy balance. Load is more, generation is less. Already if storage is there, our storage is this one. Okay, good. Then energy balance. Then other, grid link is also. Okay, so that's the second option. So ultimately this is important. So any system okay? So energy system, so energy should balance it. So generation should be demand. So you should create with the help of grid, with the help of like a battery should do that actually. And in this energy map, there are three types people are working it. Actually, one is centralized. So that means you have different nodes will be there. So maybe one node is associated with solar, another node is wind, like this and that. Then they will control techniques. I mean, so all will be centralized to one node. So through this centralized node, we will control the entire system. So this is centralized control. Maybe you have in our college you have principal. So principal is centralized system, is it right? So you will control. Then next is decentralized. So this is what decentralized. What will happen to decentralized? Department. So principal now he has given authority to different department. Head of the department he has given some all the powers. Okay. So he will control the things within the department. So this is a decentralized system. This way also you can manage. And another one is this is distributed. Distributed means it's more flexible. You can connect it any peer to peer. Suppose you want to connect it to EC department, electrical department, you want to collaborate with EC department. Then you don't need to approach principal. Directly he has an established system. You can directly contact with the EC department and you can do collaborate without contacting principal. So that way this is a more flexible here. This is a distributed one. Now these are technologies. This can be implemented in any sectors, not only electrical. So we also inspired from many other areas. And you should remember this. And we have each system has its own pros and cons, advantage, disadvantage. But people more focusing on this, decentralized and distributed based on their need and application, rather than going with centralized. And here we can introduce communication here once it's decentralized actually. So this one decentralized, centralized system actually, where we have communication is busbar also there. Where the communication we can establish this busbar, DC busbar level actually. So we have sources is there, and then converted to the DC busbar, and then converted to AC using inverters here. This is one thing. And we have one centralized converter is there. So that is top. And this is a decentralized actually with dedicated communication. Okay, now we will use the max. So now we can have a decentralized one. So this one communication busbar, you can create them and then connect to roads. So another is distributed one. So distributed one we have now. So each control unit will be associated with the different sources. That is the advantage. And we also deal with data. So any system now energy management we also deal with. Sometimes data will be structured format, something unstructured format, semi-structured data. So we have challenges. Okay, with structured data there is no problem. Suppose load data structure, because loads are known. Suppose if you want to know your home, in your home what is the loads, you know that. Similarly in your college what are the loads are there? Fixed loads. Okay, load pattern is there, load profile you already know. That means structured data. There is no worry about it. But there are sometimes unstructured data, maybe something like geometrical data, these are mechanical data, but these are varying actually. So there's a problem. And we can do a lot of forecasting things. I think yesterday also session was done, so on there. Lot of forecasting things you can do, and people are working towards this using this AML techniques for forecasting. Maybe you can use forecasting to the generation side, or you can do forecasting towards this load side also. Both sides you can do. So forecasting things you can do that, and that too short term, long term forecasting you can do. Lot of whatever conventional ML methods you can use them here also. And demand management you can do, already said. So you see the always supply should be equal to demand. Then you can have demand control one. One is price based control you can do, another is directly load based control you can do. So price based means so you can change the price of the supply. Okay, but we don't have any variation. But right now we have static. Based on the generation also you can do with renewable energy, without renewable. Because now, so what will happen is these two are varying. Is it right? Using maybe coal, maybe you get some 4 rupees or 3 rupees per unit. But whereas solar nowadays we are getting 2.5 rupees per kilowatt. So solar price is less. So like, and people are using a lot of numerical methods for energy management. So classical methods are there, using mathematics, random such methods. And then people are working with metaheuristic methods. So intelligent methods coming in where AML and deep learning methods and all this comes to intelligent methods. And a lot of metaheuristic, starting with PSOA, popular. I think faculty all remember they know it. So particles form algorithms, genetic algorithms. So a lot of things. And many things, these are all new algorithms, they inspired from other things. Okay, if you look at biology, something, life sciences, we take from those things and then we adopt our electrical engineering. Okay, many things. Maybe there is one kind of ant algorithms. How the ants will go and then search for food and then catch it and then bring it. That based on that strategy, they will implement one algorithm in electrical engineering. So honeybees. So like that, many things. Even snake algorithms are there. So many things about even game. I think you heard about game theory. Is it right? So game theory. Now game theory also you can apply to electrical engineering applications like that. Okay. And these are things, and then we have standards anyway. And we have challenge. One challenge when you deal with renewables particular. When the load is deficient. Okay. So when the load is deficient, what will happen is load is deficient, active or deficient with the frequency go down. And next is whenever frequency will rise, when I have surplus power. That means whenever you have excess power is generated. So automatically what will happen is the frequency will go up. So that is what challenge here. And but we can deal with separately. So one is grid connected and island. So in grid connected mode, we don't need to worry voltage and frequency because we are connected to grid. So grid will take care voltage regulation, frequency regulation. But whereas island in off grid, your generators are responsible because your system, so completely your generators, power electronic systems are responsible to fix this voltage and frequency. And we have stability problems again. One is supply related. And supply we have voltage and frequency. And voltage again two types, system level voltage, DC link voltage two types. And then control related to equipment. So we have two types of equipment. One is machines are there, converters are there for electronic. Again stability problem. These are all different kind of problem statements. And each problem, stability problem, there is one cause. Root cause will be there. You should see what is the problem and then what is the implications. Is it right? Some problems will come. So this is a root cause for poor control tuning is there for machine. So what will happen is undamped oscillations or periodic voltage and decrease will happen. So this is a problem actually. And yeah. So this is what primarily control functions actually. This is interesting. One can work on device level. Okay, directly that means power electronic switches are there. You can directly deal with them and then do this all the tasks, voltage and current frequency, power control, reactive power, all this. So power electronics engineers will work. And local area. So like a system level. So energy management, load management, AGC, all this thing they will do. Supervisory control, beyond that. Okay, load dispatch and the spinning reverse, black start, all this. And finally grid interactive. You will connect to a different region. So this power I will sell it to other state, other region. Then this supervisory control will grid interactive things. So this way. Mostly power electronics engineers will work with first two. And power system engineers they work last three. This is how the work will be divided. And challenges, we need to regulate voltage and frequency. This is what here. If you draw the versus frequency versus real power, voltage versus reactive power, what will happen? You are operating A point. Suddenly you will come to B. If you increase the load. Okay, frequency is go down. Then you need to take it to B and then take it to B. So this kind of group technology should use. We have controllers out there. And ultimately, why you are doing all these control techniques to get a power quality. So otherwise, we will have these problems. Sag, dips, spells, transit voltages, harmonic, reflectors, all these problems. So we have solutions also there. And we have standards. So if you look at now sag, so that's the instantaneous. So sag value should be 1.1 to 0.9 per unit as per the standard, IEC standard. Okay, then what is the time it's allowing? 0.5 to 30 cycles only. You should not create a fault beyond that actually. You should mitigate that. So now we have a challenge to mitigate the fault within the 30 cycle time. So that now you should propose a device or control unit for to mitigate that actually. And we have devices nowadays actually. Some suppressors are there, voltage regulators. Is it right? I think you know that voltage regulators. Is it right? I think sometimes you have to buy voltage regulators are there for home appliances because of maintaining power quality. Or it's a UPS system or host is there. Generators, CVT, CMA filters, FAT filters. And we have reports from IEEE also reports are there, one can refer it. These are protection I that. And this is very much important. So now IEEE one new standard amended in 2018, 1547. So this is a link established between distribution energy resource like solar and wind. So this solar and wind system can be connected to conventional power system through power interface. This we know that because to enhance the power flow. But nowadays actually we should also link these two with the communication interface. Okay, earlier standard was not referring communication interface. Now new standards are telling the communication interface. That's why electrical engineers are also working towards communication because of new things. Smart inverter. I think you got a smart inverter. In the market it's available. Okay, you can directly control the loads. Okay, it will have some kind of analysis of what are the emergency loads in the house, and it will operate them only there. So those things are done. And early standard doesn't provide any dynamic voltage support, but new standard will tell that if you want voltage support by means supply of or observe the reactive power during undervoltage. Undervoltage if you have, then what you do is you have to supply the reactive power. If it is over voltage, then you need to observe the reactive power. So that was the thing. We already know that, but they repeated in writing in the standard 2018 actually, so that we can stabilize the voltage. And we have harmonics, we have to detect it PhD. I think if you are doing any projects, I think ultimate aim is to maintain harmony. Now they relax it. If the bus voltage is less than 1 kV at PCC, distribution level. Distribution level, what is the voltage? 450, 3 phase, 50 years. So that bus bar, if the voltage is less than 1 kV, your total harmonic discharge should be 8%. Earlier it was 5%, they relaxed it. So this is what we have to maintain that actually. And similarly current also, short circuit current divided by load current. If the ratio is less than 20, then your total harmonic discharge of the current should be 5%. So that as per standard, even any product, if you look at any product in the market, if you're launching, starting with mic or car, anything, so they should follow standards. That can be IEC or IEEE or BAS, whatever it is. And these are different standard comparison actually. And this is 5% for current sector for PV system. So this is voltage harmonics. And we have good reports also. Lot of standards are there, smart grid, power wall standards are there. Another is to address effectively this climate change and global warming issues, and penetration of the renewable energy microgrids, that's one actually, and integration of EVs. This smart grid will help you with that. And we can get higher efficiency, reliability, stability, and minimize the cost. Even supply of the cost also. Per unit we are spending 6 rupees in average. Okay, whereas power plant they are spending 6 rupees per unit, but whereas domestic consumers we are consuming 3 rupees on average. Is it right? And but other sector they are giving more. But for maybe college I maybe 9 rupees. College is paying 9 rupees, and then industry they are paying more than that like that. Okay, they make some average. And ultimately use computational communication technology. In one line, what you can define, it's going to be end-to-end cyber-enabled power system. Okay, this is very interesting. Whatever you are studying, whatever we learn, only electrical power system, but that is not enough for future. Okay, it's going to be end-to-end cyber-enabled. That means generation, utilization, completely cyber-enabled. This is what the technology is coming. Already slowly is coming up actually. And we have a lot of benefits also to include more specific, any more specific answer? That is correct. Through solar, we have bidirectional. I mean, which other one? Any guess? How power can be bidirectional? Using what devices, what equipment, something. Any answer? Sorry? Somebody say. You said that? No. Somebody here. Never check that. Any idea? The answer is, one is power electronics. Power electronic devices can be bidirectional. Is it right? Say, suppose you built AC to DC rectifier. Then you can power flow from AC to DC, this side. Then DC to AC also possible. Say, for example, your house UPS is there now. UPS battery system. So what will do? To charge a battery, it will take power from the grid. Grid is AC. AC to DC conversion and then charge your battery. Then battery will give power back to loads. Then to the same converter. Again DC to AC, same thing. So through power electronics you will have bidirectional here. And of course other elements is battery also. Battery will take charging and discharging, two-way. And grid also. Grid takes the power as well as it will also deliver the power. So both things. So using power electronics, battery and grid, so we can have two-way power also. Okay, so that happens. We have characteristics. One feature is come, consumers or customers also will be part of smart grids. Very interesting. Right now, we don't have any participation. We directly connect to one distribution company. We consume that, we will pay the electricity bill. But whereas mobile phone, dish, you take it, we have a choice. We have different players are there who are giving more offers or features. We will subscribe them and then we will pay the money. But whereas electricity, we don't have any option. Is it right? We should connect to only one company that is connected to that region. But in future, you have some kind of option will come. And we can accommodate a lot of generating sources. Earlier, permissions are required. So solar, now there is no permission. Like directly you can install the solar and then connect to grid, all these things. So like this. And you can enhance the power quality. Asset optimization you can do, and then you can increase operating frequency. You can also address the problems of disturbances, attacks, natural disasters also using smart grid. And as I said in the beginning, so these smart grid technologies can be implemented at any stage of process. So don't think that only at distribution at present side. So it can be implemented starting with the generation side also. Okay. So that's why many power plants or the new power plants who are building, they are doing the smart technologies there also using wide area monitoring control techniques and all this stuff. And we have products like equipment, ICT, building, consumer, everybody is required. Everybody participation is required. And one best example is end consumer. End consumer, so peak time usage. What we do is we have solar here, and once you have solar, then I will become a consumer. Consumer means I will consume. But if you have a solar, I will also deliver the power. I will consume as well as deliver. Then I will become a consumer. So now doing that, what you do is I will look at peak time. Peak time usage. Then peak time usage, I will generate the power and sell the power to the grid at my neighbor. Then I will earn money. It's similar to concept share market. When the share price is more, what you do is sell the shares and get the profit. When the share price is go down, then you will buy the share. When you rise, you will buy, sell the power and get the profit. Same. But only thing is, you should have a dynamic pricing. Isn't it? So dynamic pricing you should be there, then you will get a benefit. So these features will come in the future. Indian also. And we have a lot of updates with IEEE Smart Grid, IEEE also, International Energy Agency. And we have India's Smart Grid Forum is there. Even BTech students, they will get internship here. Even colleges also, they can take membership. So they can take membership. And if you want latest technology, they can find it. It's a private entity but supported by the government actually. And we have one national smart grid mission is there. Okay. So right now we have target that to install 1 crore smart meters all over the country by 2025. So right now we have installed close to 50 lakhs. 50 lakhs smart meters. It's different from conventional digital meters. Everybody house now digital meters are there, but those are not smart meters. Okay, now smart meters connected with IoT technology. So the person, he doesn't need to come to your house to make a reading or something. So he will sit in control room or somewhere else. Still you will get a bill. That's what's smart. I think students sometimes they do it, prepaid bills and a lot of things, same technology. Like this. And these are the technology we are focusing right now in India. Advanced metering infra, nothing but smart meters, peak load management, power quality, outage management, that falls on the and microgrids and distribution. And these are pilot projects they sanctioned actually. So IIT Kanpur, where I visited IIT Kanpur project also 2 years back, and then smart grid projects. One they are going to Telangana, one they have project they are going. So that is somewhere else here. So the Telangana is public distribution company. And now look at this, emerging technologies. Okay, how these technologies now. IoT, machine learning, artificial big data, blockchain, data science, algorithms. We think that they are all computer science subjects. But then yes, we are using that integrated microgrid, smart grid, electric vehicles private. So these are private. That's why many researchers, students, project students, they are including this technology into this electric. Okay. Now why? Because we are now industry 4.0, cyber physical system. If we started with industry 1.0, Thomas Alva invented steam engine. Their industry revolution started. James Watt. This is James Watt, and this is Thomas Alva invented bulb, electricity, and other inventors also. And industry 0.30 computing. Right now we are there. And people are talking industry 5.0. Even last time I did one workshop in Ramchandra Engineering College. Okay, they connected industry 5.0. It's beyond that. And these are the specific applications actually. So how will it? Maybe quickly I will run through. Okay, this is very interesting. So we'll finish it as possible as possible. So these are IoT applications where you can find IoT SCADA. Right now we have SCADA system, supervisory control and data acquisition system and controller. But this is going to be IoT. Connected street public lighting. I think sometimes you do the experiments whenever people are motion, then only lights will go on and on. So the connected public lighting, smart metering, building automation, smart inverters, smart grid applications. And we can divide this IoT based on the network. Wide area network, neighborhood area, home area network. These are various applications. Where is the place, location, that is important. Based on that we have, each one is one project. Different area, okay? Based on network actually. EV related power generation, transmission and distribution. Every stage of power system we can include IoT. So starting generation to distribution. And this is the big data. So you can have utility systems and then mostly you will find the data, big data with this weather forecasting. Because solar and wind, we highly depends on data forecasting there. And then distribution side. Okay. So we have 4 types of data generally. It's a general classification for everyone. One is data gas condition. What is it? This values doesn't change at all. Fixed value. Data is motion. Every millisecond, whatever this streaming value, varying. Even voltage. If you go to power station, thermal power plant, whatever, voltage will vary. Okay, maybe 450, 414, 400, like that it will vary. Frequency also it will vary. Then it's a data in motion. And sometimes you will get a data in many forms. Structure, unstructured, mixed. Then you need to classify, segment them separately based on your thing. Sometimes you will get velocity, data and down. Suppose for example, electrical engineering, I give all the values in per unit values. The per unit is meant for 1. Highest value is 1. So 0.8 and 0.5 are equal to values. Can you describe that what is the 0.8, 0.5? It can be voltage, it can be frequency, it can be current also. Then data in doubt condition. So these ranges will come. And you will find many applications in distribution side. Because we have distribution lot of lakhs of crores of data. Rather than transmission generation compared to that, we have distribution intelligence and we have a lot of things. Okay. So customer behavior, we have crores of the people as a customer. Then you will play the big data analysis here. And forecasting things, anomaly detections, all this condition monitoring. So now how like people we go to hospital and diagnosis. Similarly in the equipment also. So they do condition monitoring. So now people are working towards digital thing. So we don't need to make any testing. So directly when we do digital thing, then sit here, I can see the performance of the machine. So like this. And blockchain is also interesting. People start with the contracts now. We can also implement for renewable energy technologies, also blockchain. Even home-to-home energy trading. Maybe my home I am generating solar. I have EV also. Then my neighbor also there. We can make starting between trading. I can sell the power to him. I can buy power from him through blockchain technology. So that's possible. And this is what application. And ML generally predictive analysis we can do. I think yesterday's session was happened. So load forecasting, generation forecasting, load detection, condition modeling, these are all things we can do. And whatever conventional algorithms are there, we can apply for electrical engineering. Same SPM, DT, whatever supervised based. Regression models you can do, classification application. Unsupervised, we can do some kind of anomaly detection, scenario generation for solar and wind. And if you go with the complex, that is reinforcement, deep learning, you can use for optimization, scheduling things we can do. So this is what machine learning for these things and all. And this is what overall. Now you can see the load forecasting, diagnosis, power system control. So all different applications we have. So these are the major applications. And AI also you can see each sector, transmission, distribution. These are the responsibilities generally, outage management, grid and all also. Each one is one task and each one is one problem statement. Okay, outage scheduling, demand forecasting, vegetation management, failures and all. Here weather defense is high. And finally your task is to improve the grid reliability, resiliency, all this. So now how many projects you can have? And similarly supply generation, these are the responsibilities, these are the case studies you can do. And finally you can get results. Okay, this is A page. Similarly, market operations, somebody interested in trading markets, then you can go this one. And consumer operations, customer, all these things. And one example, outages. You know the outages, failures. Every year we know routine rainfalls, is it right? So expected and unexpected also. And that will lead to damage in the electrical power system, substation damage, some current lines is falling down. Then electricity people will come and they restore the systems and all. Even I think Vijayawada floods also, a lot of damage is happening. Now what we can do is here, we can collect the data of weather forecasting, last previous 10 years or 5 years. Then outages, last 5 years, what are the outages happened in this particular location. Then you can classify them, what are the faults and all. Then you can build a model and train the model. And finally you can create one is outage model, all-time forest. And second one is outage model routine. That means every year, October, November, the same thing will happen. Then you can predict it, give the result. You can build an alert system for the government. They have the manual system. Then they will take the steps. So this how this AML techniques can be used for this asset management or performance practice. And this is what I was talking this thing. So every physical element asset in electrical engineering, not only electrical, everywhere, we can convert it to physical digital model using this machine learning models actually. This is trending now. So now substation now. Now earlier substation everybody is there, superintendent engineer, senior engineer, executive engineer, junior engineer. Right now there is one junior engineer. Even sometimes he will not sit. Okay, whenever the work is there, he will go open the key and then sit it. Now in future nobody will sit it. So completely remotely operated. Now we can convert this digital print technology. We can monitor and control remotely. So this is a technology. Now these things we can start with small experiment. I think people are doing. My students also done. Raspberry Pi based some temperature measurements. I think you do with Arduino also. Is it right? Temperature, humidity, and all. So that system you can convert into digital print. You don't need to sit into that environment in the table. But you sit in a classroom, but you are set up in the laboratory. But still you can control that. So that way you can build a digital thing also. Unmanned aerial vehicles also there. Data analytics also good. And now people are also working transactor. That means whenever we win the energy, obviously it should connect to the market. Is it right? We are not that directly consuming. That means we need to deal with economics also. That means sometimes we need techno-economical analysis. Is it right? Techno-economical analysis. That's what in project also faculty will ask. If you build a project, then what is the cost of the project? Is it right? So cost also important. Then you should do technical things and then economics things, then you can bring transact energy management, where demand response is the product coming to picture. So this is the last topic, cyber physical system. This cyber physical system can be used in many applications. Not only energy, healthcare, agriculture, manufacturing, everywhere. That means wherever you find physical things. Suppose now this bench is there. So this bench is no light, but still I can connect cyber. But there should be applications. Maybe I wanted to see that where is the location, whether it has been theft, how many people are occupied in this row. I want to know I'm sitting at my room. Then I will connect this thing to physical cyber actually. So that way, any physical equipment in any sector, any application, you can connect to cyber. That's possible. And this is what the CPSS, social layer. So we have cyber layer, we can build, physical layer, we have things. Okay, that's connected to residential, commercial, and all. We have social layer also. Because ultimately, the social humans, we are the decision makers sometimes. Okay, sometimes. Then we should bring the social layer also. This is what people will build. Cyber system is the actual system, cyber system, both will be and they can make us cyber systems. We have now simulation tools also there. We can make unlocking, physical system, and sometimes we do control system, electrical unlocking, mechanical unlocking. We will compare. Is it right? Control system. Similarly here also, what is the physical system, what is the cyber system unlocking. We can do modeling also, interconnected model, interaction model, interdependent model, tree model. This is interconnected. So this one now we have physical system. This physical system now I described complete modeling, differential equation constant. That will be converted to unlock to digital. That digital to that will digital will form a cyber. Once you have digital cyber, that cyber will be converted again digital to unlock and send it to perceive. This is what interconnection is. And then this is the interaction model where you mostly mathematics, okay, dynamic models like matter models or interaction model. This is how we can build. So like a physical model, this is a cyber model, then we can have interface with them. And we have tools starting with MATLAB is supporting with now cyber physics. So like the many tools are there actually. And blackout is one major thing actually. So in India it's happened in 2012. I think if you remember, I don't know which year you are studying, what you are studying. So 2012, 10 years ago, major blackout happened in North India. So complete power shutdown for them, I think almost 3 days. Even southern grid also had a lot of effect actually that time. And whenever blackout is happened, that means your complete power generation is zero. That means to start a power plant also you should have energy. Is it right? Otherwise how the coal will move and then things will operate. Okay. So then it will depend on some other alternative sources, maybe solar and other thing. Then you start the power plant. Then you start generating the energy from the power plant. Yes, this is evaluation now. So we have power system is going to be converted to smart grid. Then further cyber physical system energy, cyber social system energy. So like this is going to be trending in the future. This is one best example related to EVs actually. One you have social layer, where social layer you have EV owner with charging and discharge. Because EV owner only will decide when I should get a charging and discharge. Then you can build a social layer. So you have some kind of a pattern based on usage. And then physical layer where it is connected to aggregator. That means he is going to be connected to the grid. So he is a grid operator, like aggregator. And then the cyber layer is completely this control center where you are getting a grid control center for. So using these 3 layers, you can build cyber physical social layer system for EV charging application. So this is one good example. And then P2P energy trading also is also interesting. You look at here, this is one community, different things are happening. This is another one. So now you can give any pin to connect to any pin. So this fellow can drop off from this and this. So P2P. So there in future also it's going to happen. So you don't need to depend on the grid. So we can depend on directly our neighbors. Neighbors will give a power to us and we can give a power to the neighbors. So this is what P2P trading will happen. So that's one emerging technology now. So this is what I already said, centralized, decentralized and then distributed. Same thing here also you can apply. And game theory is one. Game theory also. So I think whatever game theory is very popular, not trending. So based on the games, based on the different constraints and all, you can come with a lot of strategies. And same game theories can be applied to electrical engineering applications also. So now we have this one best example for P2 grid trading, another is P2P. So you see the advantage here. So now we have you are selling power to the neighbor. When I compare to conventional case where you are not selling power, you are not getting any money. But including trading, we are getting the economic benefit. You are getting money, earning money. Okay, this is advantage of this. And people are building apps also, dashboards. These are all done by the electrical engineers. Okay, this is how we have a role. Sometimes you think that what is the role of I'm a good web developer. Can I give me a job? People will come to me, even as computer science students, they come to us for internship with electrical engineering. Then we stick with this kind of application. Then we have energy trading app, we should build it. I need some kind of web dashboard for electric vehicle charging station. Then this kind of task we used to do that. This is what trading will happen different homes. Home 1, home 2, home 3 like this and that. So like this. Let's take this power cord. And these are power cord. Different, you see the different things. And phasor measurement is one technology, it's a new device. Okay, where we come with phases. Based on the phases you will find. You see the phasor, one phase is out. So point. So like this. And it's always you know that receiving end voltage less than sending end voltage. Is it right? Then we have a phase difference between them. So this identification will be done by one particular device, phase measurement unit. Then we have this is one popular device now. This is part of the smart grid technologies. Now we don't need to measure the other parameters. Directly voltage is enough. Then we can have voltage and current. So these are devices. Even you can build this device using the Arduino or Raspberry Pi also. So phasor measurement unit actually. And this can be implemented for wide area monitoring system actually. These kind of devices you can implement many places and then see that what is it. And signal processing. Even ECE students, ECE graduates, engineers also they can contribute to smart grid. Because in electrical engineering, everything is now signal based, waveforms. Now the signal based processing we can do with the smart grid technology also. That's how we have one signals and system subject will be there. Is it right? It is there. So this is one of the applications. and this is lost application, wide area monitoring, and this all things will be connected. So you have a different P units, phasor measurement units connected to this node and that location, this location, that. You will capture the data using the GPS system, and then this will be centralized system actually. Okay. So some case studies already started in India actually. So a lot of advantage. This is a distribution control where conventional one is centralized one. And this all these things will be connected. Because of lack of this kind of sophisticated system in 2012, blackout is happening again. So that time they come. And different frequencies, so a lot of scheduling is mismatched and grid frequency is less than 50. And now angular separations happen. So 30th July 2012, there is no power in North India for almost 2 days actually. And now they try to stabilize them, and then that second day what will happen is they increase the frequency, it's go up to the 51, 50, it's going above 50 again. Again third day they stabilize, they brought to 50 days actually. So that time there was lack of all this sophisticated technologies actually. So and now we have a lot of cyber things. Okay, even you get a jobs also. If you're related to cyber, if you focus on using cyber, you have this kind of work nature in the core system. One is we have information technology act we are implementing, and CE also they release guidelines on cyber security in power sector 2021 after Corona, and then security governance, and then routine security, cyber security. So a lot of things. And one final observation we should make, nowadays all the technologies are synergistic, not only electrical. We are also collaborating with grid, consumer, and then operation or information technology. So that's it. So we'll conclude, and then after our session, we go to so electric vehicle I will go and talk about it. Okay, today morning what we discuss is current scenario of energy and then future demand, and next we are going with alternative solutions. We discuss about renewable energy, microgrids, smart grids, advanced technologies, AI, blockchain, cyber security, many others. Is it right? Is it right? So I think you got the people sometimes we talk about electrical engineering 2.0. Is it right? This is what? This is a movie. So that's not okay. So don't think about some things. We cannot accommodate everything in curriculum. We have BTech 4 years, 8 semesters. Okay, for teachers, everybody, and 4 years, 8 semesters. More colleges, 9 to 5, same holidays, and many new technologies coming. We cannot remove the basics and fundamentals. We cannot keep the one. So sometimes you need to work hard beyond the curriculum. So this is all we have to do. So these are one opportunity where department has facilitated this opportunity. Is it right? If the department is not giving this opportunity, I think today you will not get this knowledge. Okay, you should thank your department. And don't neglect any program they are conducting, don't neglect. Is it right? This, whatever knowledge you gain today, definitely it will be used in some way or other. Okay, even if you go to software engineer, who knows that you will be deployed into an energy related project. My friend also, one example, he was a software completely, bank projects, different areas. After 10 years, he was into one area, energy related project, that too deployed in UK, London. Distribution company, smart grids area, and whatever now he was used to attend some webinars, whatever I conducted, and then many places. He was keeping a rapport with the electrical, even though he was software engineer. That knowledge he helped him to do good projects in the UK, and he settled in the UK. So that way, don't neglect. Maybe whatever gain today, it will be useful after 10 years also. Somewhere it will come to you. Okay? We'll voice. Which answer is that? Huh? I have two questions. Okay, thank you. We'll meet in the afternoon. Okay, are you coming?
So the afternoon, the session will start by 1:20 p.m. All of you gather here by 1:20 p.m. Okay.
So, coming to the day 4, session 7. Today we are going to discuss about the reflection general. So today, resource person has spoken about the various factors that are affecting the electric vehicles. And coming to the reflection chamber. So this one is the new trend of artificial intelligence techniques in integrated energy system. So today sir spoken about the topics that are related to this artificial intelligence techniques. What are the different types of various artificial intelligence techniques that are applicable for an integrated energy system, and these are the various factors that are going to affect the operation of the electric vehicles. And final conclusion is, by applying the artificial intelligence techniques, the very fast and efficient operation of the electric vehicles has been going on. Operation of the feed-forward neural network, and in this method, how the charging of electric vehicle can be explained. And this is nothing but the support vector machine, and this one is the Hamming neural network, which was discussed in the morning today. And coming to the final conclusion of this reflecting channel, by discussing about this reflecting channel, how the state of charge method and state of health of the electric vehicles have been improved by applying the neural network techniques. So by discussing about these reflecting channels, all the points that are fulfilled by the research person today have been covered so far. And based on this neural network technique, the electric vehicle can be operated, and these are the various techniques how the neural networks can be operated, and these are the different types of the neural network circuits.
So there are some reasons actually. So why electric vehicles are emerging? So anybody can tell one or two reasons why government is pushing, why citizens are more focusing on EV vehicles. Any reasons? One or two reasons? Pollution, yes. To avoid pollution, one reason, yes. Good. Huh? Pollution. Other reasons? Cars, noise pollution, eco-friendly, fossil fuel, electric oil fuel. Okay, many reasons actually. So one is, one issue will happen, depletion of oil, gap between production and usage, that will happen next, 1 or 2 decades. That's one reason. Second is, we need to impact the global impact on the economy. Because every country economy depends on mostly fuel. Suppose if anything in the market and any price is increasing, if you go on the price, root cause for it, then it will end with the petrol and diesel. So they started, they raised it, importing the oil, and that's why the vegetables prices also increased. So that way the scenario will be there everywhere. And right now we don't have any resources for fuel in India, is it right? So we are trying to import the fuel from the mostly Arabic countries and all. So that's the reason. And we should get energy independence. That means we are generating power, we are utilizing for electricity application for whatever residential, commercial, and then industrial. But whereas now we are focusing for transportation sector also. Now let us bring the energy, our own energy. So instead of depending on from other sources, other regions. Then we can address the climate change and global warming issues. And less environmental impact after the life cycle, we can reduce noise pollution. And another advantage is regenerative braking, where it is not possible with conventional vehicle. Whenever you apply the brake, so whatever that wasting that we are getting into that braking, that will convert it. Usually that will happen in heat. So as a dissipating in heat, and then it will waste. Then we will try to tap them. So that energy will tap them and convert them to kinetic energy. Kinetic energy will connect to mechanical. Mechanical will be connected to electrical. Finally, stored in battery. So that is the regenerative braking is that's important advantage. And finally, cheaper to run. So right now, maybe if you are driving a car to travel 1 kilometer in a car, maybe petrol vehicle, easily 1 kilometer it will cost 5 rupees to 6 rupees now. In case of two-wheeler, you can calculate. You have bikes, most of you. Then 2 rupees minimum. Minimum 2 rupees or 3 rupees per 1 kilometer you are spending the money, is it right? But whereas if you go with the electric vehicle, for a car 4-wheeler, so just it takes 1 rupee per 1 kilometer. 1 rupee per 1 kilometer. then many families and individuals, you are spending 3,000, 5,000 per petrol charges per every month. Then we can drastically reduce that burden rates. So that's the greater advantage with this. But other side, there is other things also we'll discuss with other cons also there. And this is what I was talking about, gap between production usage and gap in future. So that's why we need to go with alternative. And we have 5 kind of recommendations given to all the countries actually. One is maintain and have support for electric vehicles, kickstart the heavy duty. Already we have seen the witness in the light duty vehicle, that means starting in the cars, 3-wheelers and 2-wheelers. We are getting popular. But whereas most of the energy is consumed by the heavy duty, that means buses and trucks. Where we need to introduce this electric vehicle technology, buses and trucks also, then only it is successful. And promote adoption in emerging and developing countries. That means India is emerging country. Is it right? So there are developing countries, already developing countries is there like that. And then expand EV infrastructure and smart grid. Because now it's not only you are just promoting electrical, but you need to create infrastructure, charging stations. So without charging station, how we can buy it? So that's why nowadays you see even cars also who are buying the cars, EV car, then they are using only within the surrounding of this whatever Vijayawada here. They are not traveling to other places because there is no charging station. Now you want to travel from Hyderabad to Vijayawada to Hyderabad, one place charging stations are available. Suryapet is available. And other place we want to travel to Tirupati, it's not available. So like that, okay. Even there are some agencies like these petrol pumps like Indian Oil, HPCL, PPCL. They are also entering into this business of EV charging. Even NTPC, their main job is power generating from coal. They are already entered into solar. Now they are entering into EV business. Actually, same company. Okay. So now they are trying to establish many things like this. And finally, you need to ensure the secure, resilient, sustainable EV supply chain. That means it's not once you buy it, you need to have service and maintenance. For conventional vehicle, lot of people are there. Even car mechanics, bike mechanics, everywhere is there. So you don't need to worry. Is it that if you get any repair service? People are there. For in case of EV, where the spare parts, where the mechanics, where the service point, that is the challenge. So we need to create the supply chain management system also. So based on this recommendation, we can cover EVs as well. And if you look at China is leading. Okay, in 2020 last year, China is holding 60%. Whatever cars are available in the world, 60% are cars with China only. And Bangladesh is 25 with Europe and United States 10. Ours is less than 25. Okay, and there is a goal: every other car sold globally 2025 said to be electric based on today's energy. So that is what they target. So right now, out of 3 cars, 1 car is electrical actually. So this is the EV is increasing stocks. Okay, so you can see the China, red color, and then Europe and United Nations. We are in negligible place, right? The percentage. Okay. These are the car registrations. Okay, so you can see the year 2015 it was 2010 was it started, and you can see the period after the Corona 21, 22, 23 it's rising actually. So that's a good one. So these are battery-driven vehicles and plug-in vehicles that will explain difference between them. This is the car sales 2010 to 2024, how it is exponentially rising the sales of the electric vehicle. And this is the mileage also. Mileage also, people are now climbing down 200, 300, 400 mileage per full charge also. So that is also increasing. And slowly we are increasing EV charging infrastructure. So in this there are 4 categories. One is private home, private other, private slow, public slow, and then public fast. What do you require? We require public fast charges. But whereas public fast charges percentage is less, whereas private home more percentage. Okay, so whenever we introduce public fast charges, then people will buy. They will travel to other long distances also. And then many companies also they made plans. These are all automobile companies as well. So this is all So this is one fundamental what will have in automation automobile. So we have source of energy, primary source. Maybe that you take from grid, that you take from any kind of energy resource. That you take it next step well. Sorry. So that is tank. So second one. So where you bring that well to tank. So in this tank you have maybe hydrogen, you have battery or something like. So that Then it will come to tank to vehicle. That is another conversion here. So finally vehicle to miles in the driving cycle. So this how you will evaluate performance of the any vehicle. So not only electric vehicle, any vehicle from belt to miles. So this is what many conversions will happen. Every stage you have a, again you will lose efficiency. That's why you don't get 100% efficiency from starting to ending. Okay. And this is energy domains in conventional vehicle. So you have a chemical to thermal, thermal to mechanical, mechanical to electrical, electrical to mechanical, electrical to electrical, mechanical to mechanical, so chemical to chemical, lot of energy conversion. So if you have many energy conversion process will happen, then what will happen? Your efficiency will come down. So this is what happening in the conventional vehicle. So you see typically IC engine, internal combustion based engines vehicles, they have efficiency less than 50%. Nobody is planning more than 50%. So that is a disadvantage. That means you have a fuel, petrol or diesel, whatever it is, but you are not getting efficiency. Your efficiency is less than 50. That is the problem. Like this, for electrical engineers, for many challenges are there. Mechanical engineers, they are trying best to increase the efficiency. They are not able to do that. For example, electrical also is steering conventional and induction motor. This efficiency is always less than 50. Induction motor, this, because here, so what is happening? So stator is inside, rotor is outside. It's a very typical design. Is it right? Small one, lot of jam. Then what the people, they tried, then shifted to BLDC motors. Is it? BLDC motors, inverter is there, remote control. So they did it, they increased the efficiency to above 80% easily. So that's it. But cost is more. So this fan is maybe 1200, 1300, but whereas BLDC 4000. But you can see they proved a lot of savings you can do with BLDC motors per unit. Similarly, gear also actually. So we come up with one solution, that electric battery drive. So this is what the tank to wheel efficiency. So you have tank fuel efficiency, you need to calculate engine efficiency, auxiliary clutch system, gearbox. So every stage you need to calculate, and then losses will occur. Finally, when reached to wheels, you are losing efficiency. That's a problem here. And most of the losses occurring with engine. So that's a drawback of conventional vehicle. Engine loss is 62. Then what you should do? More than 60. 2 by third. Losses will be. Then you should replace engine. So simply with battery. So that's the only solution now people brought it down. So even you can compare the technologies with the renewable energy based, with the direct charging, hydrogen based and liquid based fuel or something. So more efficiency you will get battery based vehicles actually. And here we are trying to tap the energy when you are trying to apply the brake. So that energy will come, that kinetic energy when you are applying, that will convert it to mechanical to electrical. So that we are doing it. So if you switch over, then electric cars, we can nearly 50% we can try to mitigate the CO2 emission. If you have plug-in vehicles, 40%. If you have hybrid vehicles, we can reduce 30% nearly CO2 emissions. And we see the potential. So every year we are rising it. So we are also by 2050 we are giving tough competition to developing countries in the segment of electric. That's why electric vehicles we have more. Next another 20 years. We have plenty of job opportunities also if you go with the electric vehicle technologies now. And this is 2040 also we are giving good competition for electric vehicles in the United States. But China is going to lead. Till 2050 China is leading. So no doubt about it. So types of EV, I think most of you familiar. So one is hybrid. So hybrid never plug-in. So engine battery will be there. Second one is plug-in. Engine battery plug-in, motor will plug-in option. Third one is there is no engine. We have motor and battery. So like this. And this is first one. Like you have a this hybrid. There is no plug-in. Suppose you have a gasoline or you have petrol, diesel, gas engine in there. So this fuel will drive your combustion engine. So this is connected to wheels. This is one conventional. Then when you have applied the brake through regenerative braking, that kinetic energy will become mechanical. That this motor will behave as this piston will work as a generator. This piston will work as a generator in that case. Okay, this will be prime mover. Then through power electronics, the generated power will store into battery through power electronics because this is AC generator. Then battery is AC. Then you have power electronics required. Then you store it. Then this battery can drive your vehicle. So battery power through power electronics. In that case, this machine will work as a motor. Second case. So this motor will drive your wheels. So here battery will get charging only through regenerative braking. You don't have any plug-in option. Okay. This kind of vehicles are also available in the market. So types of hybrid, one is series, parallel, combined hybrid. So you can see the series. So fuel tank, combustion engine, and then this converter, everything is series arrangement. You can find this vehicle in GM board vehicle. This is patented, they already commercialized 10 years ago. Similarly, second one, parallel hybrid, this is Honda inside vehicle. They also patented, commercialized, that is parallel, both are parallel systems actually. This is combined series parallel. Whichever you want, you can connect that way. You will find tired of race. So this whole company, they come up with the new designs actually. They patented, they commercialized actually. Nobody cannot take that model. They have patented. So second one is plug-in. Since you are giving a favor plug-in, you can accommodate more battery capacity. Previous one, you are not giving any plug-in. So here we are giving plug-in here. So now you can give a more capacity in the battery here. And third one is there is no gas, then you should accommodate more battery. Only plug-in you need to depend, and you are depending on other partially regenerative brake. So this is same. You can compare conventional vehicle and battery driven vehicle. So battery DC converter, inverter will be there because the motor is AC. AC or battery is DC. This voltage is AC high voltage required, but battery DC voltage less. Then you need to boost this DC boost. So again you need to use inverter, and then inverter will drive with motor. So that will be connected to mechanical axle wheels. And this is a series, this one. Okay, series connection. This is a parallel connection. Engine and then this battery both are parallel connection. And this is series parallel. And this is complex. You can see the complex. So rear wheels has a motor, front wheel has engine. Is that right? So front wheels is driven by the engine, where rear wheels can be driven by the motor. So now it has a battery and the inverter both will be connected bidirectional DC converter. So this is one model. And now we can understand what is the power flow in the series hybrid actually. Suppose first one is battery drive. So that means your vehicle should drive by only battery, only the battery. That means engine will be off condition. Okay. So battery, powertrain, motor, transmission, vehicle. So this is the path it will take. This will be off condition. Second one is battery recharging. That means vehicle should get the power. Who will drive the power? Give the power. Engine will. So engine will give the power to the vehicle. So engine at the same time charge your battery. That is second one. Third one is hybrid. Hybrid means you have two sources. Engine will drive as well as battery. So both engine and the battery will drive the vehicle. Sometimes you are making some hill climb. You are going to Tirumala. You need extra power. Then you can be dependent on both powers actually. And then regenerative braking. So that means engine will be in off condition. You are applying the brake. So whatever the kinetic energy convert to mechanical, mechanical to electrical, finally stored in the battery. So this is the power. And this is similarly parallel. So power system means both engine and power battery will drive your vehicle. Regenerative, that means vehicle energy will connect to battery, electrical. So battery charging, that means engine will drive. Engine power also will be stored in the battery. So ZEV, that means zero emission. Zero emission means engine will be off condition, only battery will drive. So conventional vehicle, that means engine, battery will off condition, so engine will drive your vehicle. Okay. So this way power flow, based on that you will make algorithm and the controller, so you are architect. Same for component hybrid also. So one guidelines, if you are designing power electronic converter, if that efficiency should be more than 95%. If a combined efficiency of motor and controller, then it should be 90% actually. And then these are the specifications. If I are trying to manufacture an ideal traction motor for electric vehicle application, then you should have these characteristics: high efficiency power, wide range of speed, high torque, high power density, high torque at low speeds, high power at high speeds, and wide constant speed range, dynamic fast response, less frequency and maintenance, ruggedness, robustness, fault tolerance, less noise. These are all features you should have it when you make any electric motor for ATAL application. You can compare different models in the market. So starting with the DC is outdated, nobody uses it because of low rating for it. So now people are moving with PMVDC, PMSC. Many manufacturing companies they are working, they are using it. But still induction motor in the race. Okay, induction motor still low cost, but that is giving good competition to the PMVDC motors actually in terms of power density, efficiency. But the only thing is efficiency is less compared to the PMVDC because those efficiency will be more than 90. But the induction machine you will have 85 to 90 efficiency actually. And charging, you have level 1 where you have 120, but we don't have a 1120 circuits in India. Level 2 we go with 240 voltage. And level 3 in fast charging, that is a development. Many of now coming with a lot of commercialization now. The other one is DC fast charging, that will make it using 3-phase conversion to DC. And last one is inductive, that is wireless. So there are technology, we can wirelessly transfer the power. Maybe just park your vehicle, no plug-in connection. So with 1 feet distance from ground clearance. So just park vehicle, it will transfer the energy. So from primary circuit to secondary circuit. So like that also you can do the charging also. And there are successful case studies also. In South Korea also they adopted this wireless power transfer for buses. Okay, they park there, no plug-in. So this they fully charging within our side. So this kind of case studies are true. And of course you need to have some intelligent infrastructure. That's what morning also we try to tell that smart grids will help you there. Because when you should know that as a user, if charging stations are available. If the charging stations are available, whether the charging should be available, is it that we have limited capacity because based on the resources, maybe you have some kind of connection from grid. So because you will apply for transformer, so this is what I take the transformer connection. And many vehicles also in the queue, is it right? So now what is the queue number, what is the power available, what is the payment you do that. So many things you should know that actually. So this smart grid will help you to make that interconnection. And we have one campaign is going on EV30 at the rate of 30. That means by 2030, 30% of the market share of the electric vehicle except two-wheeler, we should achieve that by 2030 in India also. So by 2030, 30% of the vehicles should be electric vehicles except two-wheelers. If we include two-wheelers, it will be more than 30%, obviously. And we have cost definitely will reduce it. Operating cost will come down. Even fuel cost also will come because electricity price is much cheaper than the fuel cost. So that we know that. So that's the advantage. But only thing is now disadvantage is battery cost. Okay, now if you buy a car now, they will give some 3 years warranty or whatever, or they will give in terms of kilometers, 1 lakh kilometers or 3 years, whichever is earlier. Like that they give that. Then if you want to replace the battery, your car is 10 lakhs rupees, EV car. Then battery cost will be typically 4 lakhs to 5 lakhs. Are you ready to spend 4 lakhs to 5 lakhs after 3 years on battery? Then you need to make some insurance kind of things and then many things. You need to, deposit money in post office, many banks and all, then invest. That is the only drawback, right? Okay? And if that cost comes down, battery cost, definitely, it's going to be much cheaper. Definitely. Okay? And it's going to come down by 2030. That's what expectation. Now people are now lithium ion, they are using it. So lithium sulfur batteries also coming soon actually. So cost will come down. Okay, then more benefits actually. But that is the duty of this material science and nanotechnology scientists actually. They are working on it actually. Chemical also. And from this picture you can see slowly the decline of conventional diesel and gasoline engine by 2030, and then rising there is electricity, hybrid, and then fuel cell vehicles. So that's what going to be give a lot of vehicles in that. And then this is what your expectation from 2010 to 2030, how many vehicles are going to be sold, plug-in as well as hybrid. So still plug-in will be there, hybrid will be there. So because we cannot switch over completely to electrical, so we cannot rely on that. So still the hybrid will continue for a few decades, another 2 decades at least actually. And this is what we started in 2009. Tesla was the first model released. I think Tesla everybody knows it, is it right? Elon Musk, you know that many users use it. So when it started actually, this one first one, and then many models have started. Okay, slowly actually. And many automobile companies they made announcements. So by particular this year we will launch this many vehicles. Okay. For example, BMW they said 2025, 25% of the vehicles will launch electric vehicles. That means slowly they are coming out from the IC engine production. They are coming out of it. They are switching out the electric vehicle. They are switching out to hydrogen vehicles now actually. So that's what many companies they made a promise. So by this year we will convert to this electric vehicles or hydrogen vehicles like this. And China target is very much high. And India we set 2 targets. One is 30% vehicles by 2030. 100% battery driven vehicles for urban buses 2030. Even in Vijayawada also you can guess. So before 2030, I think government of will push that. So all 100% battery driven vehicles in Vijayawada also you can guess. So Type 1, Type 2 cities actually. And there are some countries surprisingly they put a ban on IC engine production. So like India also we had one commitment but not in writing. By 2047 mostly. By 2047 These are the countries already they announced it. If we are banning the IC in the production, they can. So like that they have commitments. And charging we'll see. We'll see some developments in India. So India started in 2012. That was the first one where that activity started. National Electric Mobility Mission 2020. But we had partial growth that mission actually. So after that, 2015 we had launched one FAME scheme. So faster adoption of manufacturing of hybrid and electric vehicle FAME scheme. That scheme was in 2015 to 19, and then later in 19 to 2024 June it was there actually. And then ETAL also they supported this actually. And then 2017 Tata Motors they won the first public procurement EV tender. They set up the EV charging station in India, first Tata Motors. And then we had a commitment for the new vehicles 2020 by 2047 all electric vehicles. So like that we have targets. And if you want to know the details, this website. So there's such a Google FAME scheme. Like that you type it, you'll get this website actually under the Department of Heavy Industry, Ministry of Heavy Industries. So if you want to purchase any vehicle, suppose I want to purchase 2-wheeler, I want to purchase 4-wheeler. Before purchasing, go to this website and see that model is company is registered in this website or not. Because in the case of 2-wheeler, many small companies are coming, they are not at all completely registered at all. They are trying to import many things from abroad or many other sources. They put a white label, they are selling it. After some years, they come with some lot of loss, they will close the company also. So before that, carefully see this whether the model is registered under this website or not. Okay. So and then phase 1, 4 years we have sold close to 3 lakhs, 2 lakhs 80,000 vehicles are sold. Okay, 4 years 2 lakhs 80,000 vehicles are sold. Whereas Andhra government has sold 10,000 vehicles actually. So whereas other Maharashtra 36 and other Telangana is 9,000 something like that. And this is another one. So right now in phase 2, we sold 6 lakh vehicles. So around in mostly in the country, we have 10 lakhs plus electric vehicles are there on the road. 10 lakhs plus vehicles on the road right now. And we can see on the top also like what is the CO2 emissions. You can see this. So per day we are trying to what is that? So 12 lakh 6,000 CO2 emissions per day in terms of kg we are trying to reduce them. Okay, that much of incentives we are giving. Okay, so totally 36 crores CO2 kgs we try to avoid them by switching over to conventional fuel to electric vehicle. So these are all advantages actually. And this is what they list in the company. So company name, so what is the model, and whether it's 2-wheeler, 3-wheeler, 4-wheeler, if you want to detail, they will lead to their website. So if you are trying to purchase any 2-wheeler, 3-wheeler, whatever it is, so you see that whether this model is listed in this company website. If it is listed, then only you should purchase, otherwise don't purchase. Okay. And if you want to get the full details, this website. So this is maintained by DAY-4. So emfleet.gov.in. So complete details. Okay. So even there is one calculator is there. So charging maps are there, resources are there, many things are there. So many tools are available. One can explore that actually. Okay, good website actually. It's maintained by government. And this is one company, ESL, Energy Efficiency Services Limited. This is a company responsibility to establish the EV charging station in India. Okay, they have the primary responsibility. Later they have given to different state governments. State governments again they have given to distribution companies as well as other companies. In case of Andhra, so they are given to distribution companies. Whatever southern distribution company, eastern distribution company for them. As well as NetCap. We have Renewable Energy Agency there in Andhra. So they are given to NetCap also. So like. And these are the cars, popular cars. I think you heard about it. So hybrid cars. So Toyota Paris, one Honda car. So Toyota car, EMT, okay. And Maruti CR. These were the first indigenous plates. Maruti CR, I remember. And then Maruti Swift is there. Epica is there. Baleno also now hybrid is available. Glam, Vitara. So a lot of vehicles are available. And luxury model Lexus, Scorpio is available. BMW, Volvo is there. So the Innova also high class is there. That is also a hybrid. So that is also another model available. Is it right? And coming to fully electric vehicle, Mahindra E20, that was one model. And previous to that, one Reva model was there. Reva car, Bangalore based company. So later it was converted. And then Mahindra carrier company and the car. And then Tata they launched with this Tiger EV. This was the first vehicle by Tata actually. And then next is Tata Nexon EV. This is a very popular model, Tata Nexon EV nowadays in the market. And next is Hyundai Kona, and then MG ZS EV vehicle. Okay, so before Corona, after this it was there. After Corona, we had these launches recently, last 3 years actually. Toyota Tiago EV is there, Mahindra XEV 400 EV is there, MG Comet EV is there, Tata Punch. Tata Punch was launched in last year, I think, EV. So that was also getting popular now. These are the models available now. And charging stations are slowly coming up. Now, initially they focus metropolitan cities, they are coming to other cities now. In 2020, during Corona itself, we had one this charging station established in Delhi. They have 4 vehicles at a time you can charge. It will take 40 to 90 minutes based on the charging capacity. And they are charging 10 rupees per unit, 1 unit. Is it right? 1 kilowatt, they are charging 10 rupees actually. And then your fuel running cost will be there 1,25,000 rupees to 1,00,000 paisa to 150 paisa. That means even many cases it will tell us 1 kilometer we will spend 1 rupee only. Okay. And this was the charging station. This is the established government of India, EESL actually, the Energy Efficiency Service Limited. And charging, even if you type in Google also, Google will help you where the charging stations are located. That's why it is there now. And many things, parking places, you will see that even Tata Motors are there into the business. So separated for EV, auto rickshaws. Even there are some metropolitan stations like Hyderabad, Begumpet, if you visit Begumpet metro station. So from long ago it is there. I think more than 6 years they are maintaining this EV charging station there. And success of EV charging depends on 3 parameters. One is accessibility, utilization, cost. Yeah, you are going to be it. And they have given some charging stations actually in different states in 2020. For Andhra, they have given 433. But still we need to establish that. 2020 the government has sanctioned. Still we need to establish that 433. But that is a responsibility given to distribution companies. Okay, Eastern distribution company, Southern distribution company. Totally they sanctioned 2,636 actually. We are trying to still we need to establish now all this. And Andhra, these are the cities they selected. Vijayawada they said 25, 50 and 70. Even you see NTPC also in the business of EV charging station, NTPC. And then Visakhapatnam, Tirupati, Kakinada. These are the 4 stations right now they selected it now. So actually. And of course private persons also they can establish. So this is from government sector. And we have local target by 2050 we should bring that 50% light duty vehicle sales worldwide. That's another target. So whereas India we have 30% by 2030, 50% by 2050. We have IEEE also working towards that. So this is one of the peak impact of electric vehicles on peak demand. Okay. So this is we need to address it. Suppose now if we take conventional grid scenario. So like we have an agricultural sector. Agricultural sector people they use motors, induction motors. These are water pumping applications and other applications. Then what government made, they made separate lines, they made separate transformers, and the government instruct them, they made the power to specific hours, 6 hours, 8 hours, 10 hours, like that. And then they make, they said that farmers you should make arrangement for a capacity bank. Don't draw the reactive power from the grid. Is it right? So all this other way they do that. Similarly here, if you assume that lot of vehicles and thousands of vehicles coming to one same time for the charging, then our grid also will collapse. Then it should make some kind of scheduling on the peak time. So that's a challenge for electrical engineers. So where the charging should be located. So how the connection should be networked, all these things. So these are the trending research areas including electrical wireless power from my topic. So these are companies. Okay, many companies they based on kind of charging infrastructure actually. Many companies in the race. So you can put the location here. So on that state and city. Then you can try to find out what is the charging stations available here. So this kind of platforms. Suppose Hyderabad. You put a Telangana, Hyderabad. Then in this these are all private and government. So these are charging stations available in Hyderabad. Then you can try to locate them. And government said they will establish 22,000 EV chargers petrol pump, and they said So every 25 kilometers both sides highway, one charging station, and 3 kilometers by 3 kilometer radius, one charging station. That's what they try to do with the aim actually. Still going to happen, it should happen. And cost of setting up EV charging station requires one is electricity connection. First you need to approach the distribution company. Suppose I want as individual. So till this year there is no rules. Okay, any individual can set up charging station. Okay, there is no rule required. Okay, then directly go to distribution company. There is the application is there. Fill it and then give it to ask for transformer supply. KVA. How much KVA is required? That's for which you need to pay money. And then civil works, EVSC, that means charging station, not is required. So you can develop or you can buy it from other. And then technician, manpower, advertisement, promotion, and you should have a land. Is it right? So you should take a land nearby highway, then land lease you should pay. So like this. And there are some web-based applications also coming. So one company like Static, they are claiming this largest EV charging. So they like a Zomato and Swiggy, how it is. They are connected to hotels. Similarly, these fellows also will connect to charging station. You can book a slot, you can prepay, and then they will make a reservation of a slot so that whenever you go and they get the charging and get it. So like that service is also coming up now. So now charging infrastructure, these are the requirements. Okay, if you look at fast charging, 3 types are there based on the guns actually, combined charging and the Chamodo. So in this case, voltages you can see 200 to 750, 200 to 500. Both are meant for 4-wheeler. Whereas you can see that the fast charging 22 kilowatt, then it is meant for 4-wheeler, 2-wheeler, 3-wheeler also. And home charges it less than 15 kilowatt, and it is meant for most of them all. And your voltages are less, except this part. Okay, so that part you have a slow charges, DC and AC also. And you can see the battery capacity. They said up to 3.3, but actually if you look at the current models Ola, they already crossed 3 kilowatt. They are bringing the one model with 4 kilowatt. 4 kilowatt battery is there. So that what when the technology comes, ADs come, they will come beyond the battery capacity. That's a full color. But battery voltage you need to maintain 48 to 48 and whereas 3 reaches of 48, 60 and where other vehicles now. If you go to buses and trucks, okay, battery voltage may not just not below 100. It will be near 2000, even above 1000. It will be 900, 1000, 1200 voltage in case of buses and trucks. Battery voltage. This is the schematic. So where now normal charging less than 22 kilowatt. So this is what less than 1 kilowatt single phase is enough. So how do you get the 7 kilowatts? Then just you can multiply. So single phase 230. So what is the single phase 230 into your plug socket, maximum of plug socket available how much? General plug socket is 5 amperes or 6 amperes. Then beyond that you will have larger plug. So what is the capacity? 15 amperes. 15 amperes or 16 amperes. Is it right? Then you can multiply 230 into 16 amperes. So you assume your power factor is unity. Is it right? And similarly here you put a 3-phase also. So 3-phase into 3 into again voltage into again current. Okay, 35 amperes. Then you will get this power. So that means in case of up to you can go 22 kilowatt you can go. Okay, so conventional. If you want beyond 22 kilowatt, then you go with the high power. That is nothing but 3-phase. But you convert that AC to DC, rectifier. AC to DC rectifier you should use that. And these are the ways you have. Is it right? So charging. Whenever bikes or other thing. So these are the things available. But these are not converting AC to your battery is inside. Battery required DC. But whether the charges are not delivering in DC. Charging, these charges are AC to AC only. Like how you put a stabilizer for this AC. Is it right? So input is AC, output also AC. Similarly, for this also, this box also input is AC, output of AC. Same. That is called EVSC. Okay, electric vehicle supply equipment. So the conversion of AC to DC which is required to battery that will happen inside the vehicle. Okay, that's what onboard charges. Okay, so onboard charges inside the vehicle. Okay, people will kind of misunderstand. So the DC conversion will happen outside the vehicle. No, it will not happen. So it's like only AC to AC. But if you read it, so what is the any fault is there, ground fault is there, and next is any kind of how much energy you are drawing from this, so that you need to generate the bill. So energy calculation, all these things will happen this side. And even one innovation also, you can put the whatever current poles are there. So even if you have street lights in your campus, you can use the street lights, same power supply, and then establish some charging station. We don't need to establish other infrastructure. So same current code, so that you can convert it to charging station. So that is also happening. I see this model in Vishnu Engineering College, they did that. So solar, you can have solar also. Solar, you can have a charging station support, you can take there. And battery swapping, this is another technology coming. Okay, so you don't need to wait for charging. So go and take the vehicle to the charging station, and then this swapping station. So replace your battery, put your battery and take the other battery fully charged and go ahead. So that's also. But we have some advantages, disadvantages. There are barriers are there. Suppose somebody put an old aged battery, is coming to more cycles are over, then he's taking new battery. Then what will happen? So like that, then what is authentication? Is it right? It should be registered with your whatever portal. So a lot of things you need to maintain. So those are all concept of battery. And also lack of standardization. Maybe your battery model is something, their battery model is different. Then how do you support it? How do you offer service? There are challenges. So like that, many challenges are there in battery swapping. And many companies are coming. Even you look at previous slide, Indian Oil. Like that, you all petrol and diesel vehicle companies, they are slowly switching to this electric vehicle company. So many companies. Okay. And now these are some strategic projection. And these are rates tariff. If you look at Andhra, they said they charge 6.7 rupees per kilowatt. Okay, that means from a vendor. Suppose I want to establish EV charging station. Then they charge me from around 7 rupees they take from me. But I am giving to vendor which how much? It should be more than 7. Otherwise, what is the profit? I should get a returns on my investment also. Then right now people are selling for 20 rupees. 20 rupees per unit. So remaining, I should get a payback as well as profit also. This is what happened here. And these are the kind of 2 years ago. One person they bought a Tata Nexon first EV. Then battery cost is that time 7 lakhs. That means now battery cost of the vehicle 40 to 50% cost against battery. So this is one of the lacking issue right now. And if you want to establish charging station, this is the agreement. Okay, right now till as per my knowledge 2024 anybody can do it. In case of if you want to establish petrol pump, it's not easy. Government should advertise or you should have some permissions, then only lot of restrictions. But in case of EV charging, there is no permission. Anybody can install it. That right now. Maybe from 2025 onwards, definitely it may some rules and regulations. Right now, agreement copy is there. Let us make an agreement with the land holding agency and then your company, and then submit the agreement to our distribution company, apply for transformer connection. They will come and install it and start the business. That's it. Very easy now, right now. And these are standards. Actually, we inspired from IEC and then IEC standard mostly. So that is now we adopted as a BAS, Bureau of Indian Standard. These are all standards up to 7 kilowatt is a charging station, charging IS Indian Standard. Communication, this model requires 7 kilowatt Bluetooth technology. Okay, communication. And this is a plug software standard and for the EV manufacturing inlet. And similarly different DC charging and buses also like this. And this is very important standard. All the companies charging EV charging infrastructure companies, they follow this standard IEC 61851. So that is electric vehicle conductor charging system general requirements. Okay, if you are making any charging system, you are designing and manufacturing, making prototype, you want to release the market, then you should comply with your design with this standard. Otherwise, government will not allow. Okay, so like this. And similarly, second one, number 221.2. So that is EMC requirements on the right. So AC to DC. So third one is 621961. So that is electric plugs and sockets. So because already they made us standards. So these are only used as electric outside. And this is another standard for communication product. Communication for smart charging. This is standard J2847 standard actually. And you can see the standards information also in the same website. So we adopted directly IEC standard. We renamed some of them as IS Indian standard actually. So like as per our conditions and environment that we made it. And this is the DC charging system standards. Okay. So we adopted directly IEC standards actually. 21, 22, 23. Some diagrams. So this was the diagram, basic diagram. So where you get a AC, the AC will be connected to DC. You have isolation transformer, DC charge controller, directly linked to battery. Now in the vehicle there are other auxiliary systems also will be there. Is that right? So that auxiliary system again you have auxiliary power is required. So you take from the battery and all. So that way design is there. But it will also vehicle controller. And now these are the voltages maintained. For scooters, passenger vehicle up to 4 or 5 voltage they go. Buses you can go 400 to 800 voltage you can go. So DC link voltage. And this is interesting. Typical DC charging system. If you look at here, this battery only inside the vehicle. Okay. So battery is inside the vehicle. Whatever this conversion is outside the vehicle. Outside. So AC will be again converted to rectified AC to DC power factor correction. Then you have non-regulated DC, you have inverter, you have one transformer. Again you do the AC to DC because battery is required DC. So multi-conversion. But all the conversion will happen outside the vehicle. That means this is off-board charge. So only battery is inside the vehicle. And look at here, charge controller is inside the vehicle. Second. Charge control inside the vehicle, but AC to DC will happen outside the vehicle. That is also possible. Look at this. So only battery is inside the vehicle, but DC is outside DC charge. So here the transformer we brought it front. Okay, primary side. Okay, that's one actually. And look at this last one. So here we are not depending on AC switch. Maybe you have a solar. So directly take the solar power as DC. Then convert them DC non-regulated to regulated and give it to battery. We are not depending AC, so we are depending fully on solar power center. And we have communication. And similarly AC standards also, we have these standards. There are Indian standards. We have this slow charger, fast charger. According to that, we have to select the cables also. Based on the fast charger, A cable, slow chargers, A cable, AC fast charger, then we should EV, SPP, EV, the D-type cable is used. We have mobiles, so whatever types here, whatever. Similarly here, cables also there. And we have full vehicle charging standards are there from different countries. And battery pack standards also there. That means technology is proven. So once it's proven, then only we make standards. So standards are available, then now people are looking towards commercialized technology. So even wireless charging also there are standards are available. Wireless methods. So now slowly somebody has to bring it to market. So that's the thing we But for with EVs, so this is what we already understand actually. Level 1, level 2, so this is the electric vehicle inside the thing. So EV charging system that's outside. So that is off-board. So this is vehicle to grid. This one concept is interesting. So somebody should think about it. So right now, we know that grid to vehicle grid. Is it right? Grid to vehicle, what is that? You want to charge your battery. But we think about vehicle to grid. You are transferring energy from vehicle to grid. Why you should transfer to what is the necessity? Is it right? But there should be some profit, Okay. In future, what will happen is maybe suppose you are not using vehicle. Okay, dynamic pricing is there. So that time high price peak time is there. So you are not using the vehicle. You can sell the power to the grid. Maybe 10 rupees per unit. And other time in the morning only 6 rupees are there. Then you consume the power 6 rupees per unit you consume the power. So that way you can do the vehicle to grid connection also. Okay, a lot of case studies also there. And then these are the level 1, level 2 charging, and then these are charging stations actually. Okay. And level 1 we go up to 2 kilowatt, 17 hours, and whereas 8 hours it is 7 hours and 30 minutes actually. If you purchase some kind of vehicle now, Tata Tiago is there. It gives battery capacities, they give like this one. Battery 21 kilowatt they give. 21 kilowatt and 22 kilowatt they give motor battery capacity. And they give the charger is only 7 kilowatt charge. Then to get a full charging, how many hours? How many hours? 3 hours. But if you go to the basic model, they are giving a 3 kilowatt charge. Then you require 7 hours minimum. Okay, that's right now it's happening. Okay, that means you get a full charging of Tata Tiago vehicle. So you need to wait for 6 to 7 hours, right? Okay, because we have a limitation actually. Because that is connected to single phase 230 voltage 6 volt spec. So that's the reason, right? And these are types of plugs. Okay, different type 1, type 2, type 3, type 4, something or not. So that way it is easy, right? So based on the levels, level 1. So first one is level 1, level 2, small one is suitable. That is, this is European connection. This is level 3 for combined for DC. So like this. And we can compare with public conditions. So what is the difference between this charger plugs and all. This is what charging station inside. Earlier I showed you one picture what is kind of box. So that in that what will happen is in AC to DC. So this is only conversion will do, not even conversion. So you take the single phase line, so line and neutral, and you have a voltage current sensor and voltage sensor are there, from which you will try to do measurement log, and you will calculate what is the energy you are drawing from the grid. So thereby you calculate what is the energy consumed. Thereby you will get a bill. So this much energy consumed, you need to pay. So this micrometer will give this internet system, it will display here, and then you need to pay money. So like this. But here, what is it coming here? Directly it's coming to plug-in. So like this. So here we are not doing any conversion AC to DC. Only AC to AC only. But we are trying to find the faults, and we are trying to find what is the energy consumed from grid to vehicle. So that these two only will work. And you have this microcontroller required power supply. So then you should have a power supply unit, and then regulator is there, and then communication. So people, user wanted to use communication with mobile app or web-based, all these things. Then you should have a communication protocols, all these things. And somebody wanted to see display. So open interface display is required. Some kind of smart TV and all these things. So similar to DC charging also. Okay. So same. This is again DC charging, and AC to DC will happen, DC to DC, and it goes away. Can goes for the protocol. This is another trending area. So BMS in vehicles and vehicle different VM. So now, as per standards, your battery should have some specific features actually. So one is high energy density, and that's required, and then it should have deep discharge characteristics, and it should have a long life, and then wide acceptability of the recycling of battery. This is also another area where you can focus as an entrepreneur now. So recycling of the EV batteries, that's another idea. And then this is what battery technology trending now. So right now we are in lithium polymer. Same picture in that lithium ion. So lithium polymer batteries and lithium sulfur. Even our mobile phone lithium polymer batteries. That's why it's very thin. So lithium polymer and lithium sulfur batteries also coming up in the future. And why lithium ion we are emphasizing now? So specific energy and specific power. So it has more for lithium ion when compared to lead acid, nickel metal, nickel cadmium batteries and all. Based on these characteristics, and the lithium ion having better characteristics. So that's the reason we are doing lithium ion batteries like. Do you compare it? Okay. So different lead acid, nickel metal, lithium ion. Then you can see the obviously. Even self-discharge rate is lithium ion battery is 5%. Even if sometimes you know that is it right? Even laptop, even mobile phone, don't use it. Even car also. But after a few days, whether the charging percentage will be same? No. That was self-discharge. So this self-discharge percentage will be less for the lithium ion battery. Whereas other batteries is more. Okay, you don't use it. Okay. And targets to extend the battery life at least 10 years. People are talking about only 3 years, 4 years, they want to give warranty. At least we want 10 years. And then we should cut the battery cost significantly. So that is one now. Now you see some implications in the reality. So causes of EV battery failures. Is it right? You order for fire accidents, EV batteries, short circuit, many things. And many things, 5 caught during the short circuit by collision, and 5 caught by charging, 14%, 5 caught overcharging, 5 caught charging equipment failure, combustion, spontaneous combustion 38%. So battery pack soft, they are not properly soft the battery pack. So then 5% that is leading. External factors, all these things. And you see some kind of news, fire accident, battery leaks. Even Andhra also, in Hyderabad, in Vijayawada also it happened. So this was 1 year. So 3 people are injured in Vijayawada. Okay, so many accidents happened. And government also said a lot of warnings. They recalled 2 years ago these 3 companies, Ola, Economo and QRV. 600 vehicles they return. They took taken from the users. Again they sold they have given new vehicles to the bank. They made a replacement. What they do. So like this there is a lot of punishment also. But what is happening now? There are a lot of factors affecting battery efficiency. So this is one axis. So frequency of charging and discharge. Is it right? So your phone also. Every day 10 times you make a charge. What will happen? So number of cycles is over and whatever less than warranty period will get over. Similar thing. And then discharge rate, discharge time, and total charge time, battery storage, temperature, operating conditions, many factors. And sometimes battery failures due to operating conditions. Where you are operating, some kind of vibration, temperature, all these things and all. So sometimes battery excessive charging. Sometimes your friends will tell you get it charging and then even 100% you don't remove the plug. Is it right? So that means some kind of studies will tell that overheating. Is it right? So that was excessive battery charging also will happen. Sometimes inadequate battery charging. You will keep your batteries completely dead. All the time, many times you keep dead 0%. Then that will also even problem. There are all general problems for battery. And then storage conditions. Okay. And this is one technology hybrid where you can combine with battery with ultra capacity. There are some dynamic conditions required where you need some extra surge power is required. Then battery and then ultra capacity can have series parallel connection and then inverter and then motor. And then here DC cannot be inverted. Here, whereas here both voltages are same, but here it is not the same. That's why DC. And then this active topology you have a diode to provide unidirectional path. And this is reverse. You look at this picture and this picture. So the placement of UV and then battery is reverse. Okay. And then this is both battery and ultra capacitor parallel. So this one battery and ultra capacitor, whichever you want it connected, reconfiguration. So that way. And here three parameters we are going to sense it. One is voltage, current and temperature. So during charging and discharging along with the ambient temperature, that's important. And objective of BMS is we need to protect our battery cells from abuse. So you see the battery pack. So a complete battery pack size will be there, maybe for 2-wheeler. If you open the pack, so everything like in the models will have, finally you will find a cells. Whatever you have a normal cells, maybe this remote has a normal cells. So the same similar size you will find a lithium ion cells. So that lithium cells will be connected in series parallel combination to get this your battery. So that will be connected. Now we need to protect the cells. What happens is here objective is so we need to find which cell is damaged. Suppose 100 cells are made as pack. Okay, your efficiency is completed. Your duty is which cell is now out. It's very challenging. We need to open complete pack, identify each cell, whether it is working or not. So these are all challenges in electrical engineering. And extend the battery life as long as possible, as already impressed in 10 years maybe. And make sure that battery is always ready to start. This is again issue, is it right? Even your scooty bike, we don't use it for 10 days. What will happen is it will not start with automatic. You need to kick start. Even petrol vehicle, your car is there, your vehicle is there. You don't use for 1 month, it won't start easily. Again, you need to ignite your battery and get started. So these are all general problems associated with vehicle batteries and all. So this is a problem. But we need to overcome with this BMS technologies and all here. And here what we do is different functions we need to do. Charge controller, discharging controller, state of art, state of health, cell balancing. So that means whatever cells are there in the battery, all the cells should maintain ideally same voltage. Okay, but practically it will not happen, but you need to maintain that. And thermal management, data acquisition, logbook will help you in service. So it will maintain that you previously went to do the service. Again, what is the problem? Based on the logbook, you need to maintain it. Even if you go to service center, whatever Tata, whatever Suzuki, they will maintain a logbook. So they will enter online system, a car number, everything. So you will get to know whether previously went to come and then what kind of service you made. So that will help you. Even for medical also. I go to hospital, I will bring previously. So what the doctor will analyze based on my past history of health, then he will diagnose it easy. So same way here also you need to maintain logbook. And here we can understand this way, distributed modular centralized actually. Morning also we discussed what is the advantages similar. So here distributed, you can see the cells are packed in. Each one is one source. There is a disadvantage here. And second one is modular. This is one modular pack, second pack. maybe this is a 1 kilowatt pack, so another 1 kilowatt pack, so then it becomes 2 kilowatt. So like that you can do. And this is centralized logic where all the things will be connected to one master controller. And this is a scheme. So first we need to send voltage, current, temperature and give it to our microcontroller. So then microcontroller will make state estimation, that is SOC, and then you will go to user interface. Then user will decide. So he will decide my charging percentage is 30%. My mobile is now 25%, 30%. Wait, you go to user, it will come there as a display. Then I will get a charging. So that's what user interface. Some of the things maybe you will go to directly, automatic. It will go to electrical control, maybe thermal. So thermal heat is appeared. Then directly you go to electrical control, you will switch on some coolant. So coolant again two types. One is with oil, whatever liquid. So using liquid flow, you can have coolant. So other one is maybe you can switch on some coolant fan. Sometimes exhaust fans you put in your kitchens or whatever. So same way here also maybe some coolant fan is there. So like that you should provide thermal management here. And this is the same diagram. And here we have two components. One is hardware, software. So hardware, circuit, sensors, microcontroller, charge control circuit, communication boards, thermal management, maybe coolant fan and all. These are all hardware models. And these are all software. We need to write algorithm. So SOC algorithm, SOH, balancing, fault detection, user interface. So combination of hardware and software, then you can build a BMS for that. So this is not so now people are applying machine learning. So here also. So to analyze the battery BMS, so people are trying to find the SOC, state of charge, state of SOH, state of health. People are using machine learning conventional. And SOC is a simple way. So the ratio of currently available capacity to maximum capacity SOC. Okay. So now where you can see the formula, Cn is the maximum capacity that battery can hold it. So that means whatever now percentage is mobile now, so that is what that is SOC. Okay. So currently available capacity to maximum capacity. So that is even your laptop, everywhere, wherever charging is there, percentage, that is SOC only. Okay. And we have methods, coolant pump, thermal filter, many methods also there. Now we go to SOH. See that SOH? So C0 divided by CT divided by C0. So where CT is capacity estimate that time t, and C0 is new battery capacity now. That means your battery capacity you need to compare with new battery. Because always now you purchase a mobile phone, initially it will come 3 days, 4 days. Laptop, how much? 5 hours it will come. But slowly what will happen? This will come to 0 minutes. So it will come 1 day, half day, 2 hours, 3 hours, then it will replace your phone. Similarly, laptop also, is it right? 5 hours it will come. Finally it will come to 0 minutes. Is it right? Because you try to do aging. So that's why you need to find out health condition. That means your battery capacity you need to compare with new battery. That's what difference between SOC and SOH. Is it right? So in our mobile phones and laptop we know only SOC only. But if you know the SOH calculation, that's good. This can you can take one project. Finding out SOH for mobiles and laptops. Can you tell? Challenging now. What is it? It's the same thing, but battery, people are running it. And another one is SOL, similar. So you know like a mileage, okay, based on your driving pattern or whatever. So now you know the SOC and SOH. Can you not able to tell SOH what is the life? So that I will get to know if you go on continuing the same driving cycle per day, this many kilometers battery usage, then next another 15 days you need to replace your battery. This kind of alerts will get it. Is it right? So because EV batteries are not available, don't think that you should go some Kirana market and then get some not like that. You need to wait, you need to book a order. It should come from manufacturer. Okay, even manufacturer. It will take a lot of time, days, even months also. That's why we need to find out what is SOH and SOL and make a pre-order for your battery replacement. That is necessary. Okay. And vehicle to grid is we discussed it. I tell you one case study. So in 2011, Japan there was a earthquake happened. Complete shutdown was there, power shutdown. Then what happened is there is one Nissan Leaf vehicle. This is Nissan Leaf is one model name. Okay. So 66 vehicle they given power back to the grid to stabilize the grid. Okay, that means your vehicles also can supply the power. Is it right? Now power is gone, but what you do immediately? You switch on diesel engine. Is it right? Diesel engine. Synchronous generator is there, diesel engine is there. You got the power. Similarly, your vehicle can be used for your applications. So in future, if you know, it's going to replace your home EPS systems also. You have some EPS system battery is there. So using your home EPS battery system, then use your car battery. So home EPS system maybe 600 VA, 1 kVA, 2 kVA maximum, 3 kVA maximum. But car battery 20 kVA. Is it right? Then use the car battery for your home. And whenever you want to do some functions, wherever you don't call this engine for it. Then you call the car. Wherever your friend who is having the car, electric car, then you call him and you give money at the best price, and he will deliver the power to your function hall. So this way you can earn money also. So that's what applications of B2G, vehicle to grid. So you can find out vehicle to home also. Vehicle to home, vehicle to building. Okay, you can supply energy to home and buildings also. This is what it is. And one can work on this smart energy management system. Let us assume that there are charging stations are 1, 2, 3, 4. Okay, charging charging. How do you maintain these all charging stations? The collaboration. Because charging is not available, you should direct your user. Okay, you should other charging stations nearby, charging is available. So go and get it done. So let us make a reservation. So this kind of charging. Maybe assume that this all charging stations belong to one vendor. I have joined the owner. So I have 4 charging stations. I need to again integrate. So that's what it is. And right now we have one protocol we use, connection between EVSP, electric vehicle supply equipment in electric vehicle. So that was open charge point protocol. So it's the open source, open cost. Some scientists, engineers, they made it research there. So open cost, nobody wanted to purchase it, it's free. And people can use it. Even one batch, internship batch, they did one BTech project under me also. So they developed one protocol based on this one for charging station. So based on Python programming, they use the AWS actually. So like this. And one can make AC and DC also both. So that is also possible. And of course, cyber is another one where you can look at sometimes you will also surprise that many faculty and engineers from computer science, they work towards this. Even our NIT also one faculty was there, so he was working on wireless chargings. Okay, from electrical point of everything. So, but he is complete background on computer science. So we have good cyber security reports in that. And sometimes big companies also they join hands together. Honda and Jeep, very big companies. Still they work together. So even also you see some collaboration. Even Tata also collaborated with Hitachi, and SRS collaborated with something like that. Is it right? So many big companies also they join hands, they come up with new ideas for new technologies and all. And this one company, vehicle to grid technology, they focus on it. And ABP also. And this is the P2X. This is very popular now. P2X means you can connect the vehicle to anything. Already I give an example. Vehicle to grid, vehicle to home, vehicle to building, vehicle to particular thing. So vehicle to X means vehicle to anything you can connect. So that is possible. And you have many employment opportunities. You search into whatever, and you will get thousands of jobs in electric vehicle nowadays. And then government also giving a lot of trainings also. They are giving that. And some interesting literature review. One paper I will just tell you. In this one particular paper, the authors have reviewed 2000 plus papers. Generally, if you read the paper, at the end of the paper, they give 10, 20, 50 references. But in this paper, they quoted 2000 references. Which are the areas are connected to EVs? Power quality, scenario study, electric markets, demand response, demand management, vehicle to grid, battery management, all these things. It's a good paper. This one case study, very simple. Okay, it seems to be simple, but somewhat you should put effort for this. You have solar is there, you generated power here, PC, and you try to power from grid. It is a bidirectional. So you can take the power from grid or you can power the power from grid. So this is a battery, you charge the battery and discharge the battery. So now you have complete AC. So you have 5 vehicles. Let us assume this is charging station. Charging station, there are 5 control units are there, charging chargers. So 5 vehicles are coming. But the challenge is now, all the 5 vehicles won't come at a time. All the vehicles are same, not same model, same company. Is that right? So So a lot of things to it. All the vehicles may not having the same power is required. Maybe some vehicle will come with 30% charging. Some vehicle will come 20. Some vehicle will come 30 to 70% already charged. Is it right? Lot of constraints will be there. Then how do you do the power management? Is it right? Then you make an algorithm. So let us test with what is the SOC of these batteries. Then find out, So here is economical is you drawing power from the solar is economical. Drawing power from the grid. Is it right? Your own solar, you can generate power with less power. So you need to see that which is optimized way with the low cost. You should tell me that now one vehicle has come. So whether drawing power from the grid, whether drawing from the battery or solar, which is best? Economically cheaper. Then you should write algorithm. So what is you should see that what is the solar power available. If the solar power is available, then you get from power from the EV charging. Okay. If the solar power is not available, you take from the grid or battery. Then finally you should schedule the PV charge. PV schedule. So PV should get charged for next cycle of take off. And then here you can classify. So you want fast mode, slow mode, average mode. You can give option to somebody I want to do slow charging. Why? They charge less money. I will take fast mode. Then they charge more money. I want to go quickly. So instead of that I will pay double money. So I do that. Now let us give these constraints for them. Now build algorithm. Okay, new vehicle arrives. Ask him where he wants whether fast mode, slow mode, average mode. So in between you can change it. Some if in the average mode, then you can switch over to slow mode also. And here also you can have the option. He initially got charging for fast charging, but he switched over to average mode, and then finally he switched over to slow charging mode. Okay, that way you get flexibility to him. Then you can write algorithm. I think in the morning we discussed this IoT option also. And directional charge of the CV. So one is for us specially designed electric motors. India we are not designing ideal. There are very few companies designing electric motors. Motors are designing but our own other purpose. For electric vehicle application nobody is manufacturing. Very less companies. One or two companies. Okay. But everybody is importing from other countries, particularly from China. Now we have a scope to design our own electric motors. But point is disappointing thing. Very few academicians and researchers they are into design domain of electrical machines. There are people who are there, they retired, they passed out, but nobody is there to design electrical motors. If you want to grow, so this is a unique area. You will become a unique person in the industry. You can become a motor design engineer. The people diploma graduate, they do the motor winding. They have a lot of demand. But if you do the same winding for this kind of EV vehicles, I think we have a better opportunities in EV industry. That's one step. And next is multi-level inverters. Because to drive the motor, you should have inverter. So inverter technologies are there, multi-level. Same that different purposes. And then parallel inverters are there. Hybrid source. Morning we discussed this kind this. So we have more than one source. So battery we have a conventional fuel, gas, petrol, diesel. Battery with fuel cell, hybrid. So like this. And then next generation batteries, battery management system, EV charging infrastructure, static, dynamic, wireless, 3 categories. Okay. And then renewable energy based charge. Then maybe your charging station having solar, then you get the charging is one thing. Then vehicle to grid, vehicle to anything. And then integration with microgrid software because you don't need to depend on conventional grid. You bring your microgrid and give the power to the charging station. That's possible. Demand response transactor because you are dealing with academics finally and smart charging management. And then cyber physical based solutions also. And this topic. And these are the future vehicles beyond EVs. Hydrogen vehicles, government already started hydrogen mission. Is it right? Even they are about to launch it, they stopped it, they deferred it. So last week, there was one ethanol plant they were supposed to launch in Visakhapatnam. They had to start it. So hydrogen. So even Toyota also already entered into the market. Okay. So hydrogen vehicles now very much competitive to the electric vehicles. This is another very good area. And then solar vehicles, all electric aircrafts. Aircrafts also much expensive. Now let us bring electricity into that actually. Aircrafts also become very much cheap in the future. It becomes instead of depending on the fuel, then it depends on electricity. Then autonomous cars, virtual cars, flying cars. If you have money, there are some two companies are there. They are buying. They are selling flying cars also there. There are two Fertiga and Ferratuga, two companies. They are selling the flying cars. Okay, so you can park your vehicle. Okay, and then we get inside, take the flight. Fly, and directly you can land your home. Those vehicles also available. Okay. And this is about I'm coming to the end of the presentation. Maybe I'll take another 10 minutes. Okay. So here are some general things which may be required for your career, for BTech graduates. And little bit I talk about faculty development also. One is possible routes for career. If you complete a BTech, what are the options for you? I think now at least somebody is sleeping, somebody is still watching mobiles. At least you should see this is important. Maybe other materials are, if you search in internet, you will get it. No issue. But these things you don't get it anywhere. Nobody will tell you. Maybe that also some materials. Yeah. Yes. yes. Maybe at least this topic you can learn. This is very much important for all of you, please. Okay. So one option is higher education. You can go to higher education. Okay, after BTech in India and abroad. Okay, that's one option. I tell you what is higher education also. Next is if you don't get enough placement or job immediately, what you do is they simply sitting at home, or they go to some Hyderabad, Andhrapradesh or something. They do some courses. They lay down this time. That is not correct. Immediately you should go to some internship. Okay, this internship opportunity should showcase that my experience. So now come to me as experienced fellow, it's called zero experience. So through internship you can go for jobs. They are not telling. They are watching movie. So next is training opportunities. Other small companies are there where you go to trainings. Even they pay, they don't pay. Still that experience is good for you. So that you go there. Next is placements. Anyway, in institute placements are off campus. But students generally they don't go for off campus placements. You depends on only campus. And that is you want comfort. There is no company should come here. Then along with my friends, together we write exam. Then only we select. But after that, everybody is going different directions. But there are many off campuses in Hyderabad, Bangalore, Chennai. If you go to some season, particularly this April, May, June, July, August, every weekend there are a lot of placements will be there, offline campus, where you can go and participate and get the jobs also. But students, they never go there. You should go it. First is awareness is not there. You don't know the opportunity first of all, first one. Even if you know what is that Hyderabad, this is the place, this is the time, but still you don't go it. Maybe you may go, but others don't. They feel some inconvenience why I should go and then whether I could get a job or not, something. Many doubts. So that's the thing. But if you go to off-campus job, and you will get a better choice also. So that we should try. And then state government, central government, that will job test interviews. Is it right? So government two types. State government. Always central government is better. You have more salary and benefits will be good for central government generally. Next is IT company job opportunity through job portals. Go to CV where you can upload your CV and then get the jobs, and that way the general things will go. And then or you can go with your own startup venture company. Is it right? You become entrepreneur. So that is also good. Or one can go civil service defense. IAS, IPS, whatever it is, then go to civil service, write it. Okay, preliminary mains. And then you can go to defense, Navy, Air Force, one more, Army. So in three, they take BTech electrical also. Even many of my students also, they are in Navy, they are in Air Force also. As engineers, after BTech first year, okay, you can also get the opportunity. While BTech final year, you can apply that. Secretly, they have medical ground test will be there. Then you pass out, you will training. And then you will become a flight engineer, you will become a control engineer, like that in Navy, Air Force, you will get a jobs. BTech first year. So that you go defense also. Good jobs. And finally, you have four options generally. Okay, one is public sector, government, central government, state government, higher studies or research. Another is multinational companies. People will prefer it. Instead of going with a small company, they go with multinational companies, So they're better service. And where we focus on operations and R&D. Or you can have other fourth one is startup. You want to make your own startup and recruit your own friends as employees or partners, whatever it is, that you can do. So broadly, these are the career options. So higher education, one can do MS research. After BTech, MS is not up in India. People will go with other countries, MS. But mostly that is not with the aim. My friends are going, my previous people are going, I wanted to go, and then I settle there like this. Everything is expensive only, isn't it? So that is not go better idea. Then next is MT and MTech. There are two options. You can go there, MTech means you better go to a PhD. And MBA also. BTech with MBA is good combination. You will get a market a lot of demand. So a lot of salary also very much high when compared to conventional engineering. So MBA also very good actually. People will go just by CAP, GMAT, many things will write it actually. Very good. Even people will write after BTech law. That is also now trending. So you can become some kind of a lawyer, judge in Supreme Court, High Court. So you have a lot of even corporate companies also they hire this consultants actually. You will get a starting package is 2 lakhs per month starting salary. So if you complete BTech with law, engineering background with law, I think you have 2 lakhs per month starting salary. So this way a lot of training things are happening with the higher education. Or you can go and PhD abroad, that too after master. That's only. So in India, PhD in India. So generally, if you are here from college, so then you should go master's MTech and then PhD. That's one thing. Even if you have you have 100% chance to study in the IIT. Somebody say that I wrote IIT JEE, but I missed it. Still I am studying in this college. Anybody is there? Yeah. But still you have 100% chance. You can just still you have a chance to study in IITs, and then it will become a faculty in IIT also. Is it right? You will look at many professors who studied in a small engineering college, BTech, but still they are working as a faculty in IITs, IIT Bombay, IIT Delhi. So you have a choice. So like this. And then interdisciplinary also there. That is also maybe BTech one branch, another is MTech is other PhD that way. And public sector in the government, we have these are the companies in India. 300 companies are there, government companies, central government. So 8 Maharatna, 16 Navaratna, 17 Mini Ratna. So starting package itself will get more than 10 lakhs. If you want central government job, you should not ask your department or parents anybody. Simply write GATE exam. So that is roughly 10 onwards. Before that there was every company they need to write the exam. But 2010 onwards, you need to write a GATE exam, crack it. So through GATE apply for 300 companies, your starting salary is more than 10 lakhs per annum. And then you will join as BTech training, engineering training. You will become a chairman of the company. Suppose ISRO is joined training, but after 30 years you will become ISRO chairman. NTPC is joined training, but after 25 years you become chairman of the NTPC. That kind of elevation is anyway will be there. Okay, but you need to crack the gate. You should not ask your department and you come job. That's it. Okay. And these are Maharatna companies, NTPC, ONGC, BHCL, IOCL, GAIL, BPCL. Navaratna, they started with 7 and 9. They increased to 14. BA, PEL, DAL, HAL, NALCO, NMDC, many others. And other career options like this, you have in general trending market. So software developers, data scientist, machine learning engineer, bank operations manager, program analyst, cybersecurity, blockchain. These are all different things. Is it right? Yeah. And many of people, they are not joining jobs actually. They have very good potential. They are working as freelancers. So when you go to the jobs, you have to work for one fellow only, you need to draw one salary only. But whereas people, many my own friends also, they have very good caliber, they sit at home only. They have a laptop, internet, but they do per day from 10 jobs. They get 10 salaries. Like consultants and freelancers, they earn more than 10 lakhs per month. So like that also, if you have caliber, you can do that also. And then slowly what they do one day, they start their own company. They recruit the people. Because they have money already. So like this. And sometimes you will have misunderstanding that there are some companies they are meant for software companies. For example, TCS. So Tata Consulting. It's normal, software company, IT company. It's a technology-based company. Many of my friends in Tata Consulting, TCS, they work in EV. Tata TCS, they have EV domain. So electric vehicle mobility is there. So they are working there. So they are working in wireless charging. Wireless charging, for electronics is there, Tata TCS. So like that, you should don't judge that it's simply IT company and all. So you should go with the profile and talk to the people and then take decisions. And Intel also, look at this Intel. So generally private companies, electrical, electronics, ECE, EEE and then comparison, they treat equally all three branches. Okay, electrical, electronics and comparison, all three branches. For example, Intel, every year they recruit fresh engineers. All three branches are equal. Only thing is they describe the job description, whether you have requirements or not. You need to prove them through your CV. And similarly, Qualcomm, every year they have college graduate fresher. Okay, but again same, BTech, ECE, EEE and then comparison same for them. Only thing is whether you are meeting the requirements or not. That's it. And anybody can apply, anybody, any college or not. And doubts sometimes, government job, better job, which one? Product based service. Personally, I advise you, let us go with first as a career product based company, then switch over to service based company. So if you get into service based company, you never come back to product based company. Is it right? You don't have experience. So even I have like product based company. So I will have more experience. Then I will go to service based company, I will become a manager. But when you go the reverse, you will not have. Okay, you don't have experience doing that. And transition from academic to industry. Suppose you have a passion to, I want to become a teacher. Okay, you work for 5 years, 10 years, still you have a chance to go to industry. Many of my friends, even NRI also, so they have 10 years, 6 years experience. They went to industry. Last year also one faculty, he went to Tata Elxsi. He has 5 years teaching experience, and still he went to Tata Elxsi. But he improved that. So why he is going and why he has to take it? And he has shown some through his publication project. But yes, I have this, I have skipped them, that's why I am applying. So you can also come back industry academia. If you have 10 years experience, you come to same college, they will take you professor of practice. They will be salary here. So that is also possible. Okay. And hierarchy, and then finally people will talk about your experience and skill. Once you graduate, people will talk about only your experience and skill. They won't even talk about what is your college, what is your CGPA, give you marks, nobody will ask you. Okay, maybe those are required only first job only. Once you get into first job, experience and skills only matter. That maybe sometimes we see that there is one fellow last year and he has so many backlogs. He 4 years BTech, he give 5 years or 6 years. But we call him after 10 years. He is a better person. But everything he take with his skills and experience of, he will realize things will not easy like like academics. They will force you in the job. So that's it. And advise in Python, because industry Python is ready. Okay, if you go to software or even technical also, people are asking Python, so learn Python. Okay, it's now compulsory. Okay, Python is compulsory. And you can also depend on open source software coding and coding and all. Because it's easy, free to use, free to share, free to change, free to sell your work also. So that's open source. And this is meant for faculty. So faculty have 4 things they can do. So one is they can publish the papers, journals, conference, book chapters. Other one is they can go with instead of publication, they can go with intellectual property, patents and technology transfer. Another is funded project from government, state government, central government, international industry. And fourth one is consultancy project from industry, government or startup venture. Okay, any faculty has this opportunity. Even if you become a faculty, I think you have these 4 bits. So primarily we do all the things like. And writing skills are important. Okay, but Indian country is writing, but we need to improve writing skills. You may do for a project, but you need to prove that ultimately for your client, you need to submit a document. Is it right? So for which you need to enhance your writing skills also. So this is project where I split this. You have to do project. I take separate session. I'll come some other time. I'll tell you how to do project. So these are the trending areas in electrical engineers. Okay. So from which you can take projects. These are all areas for electronics, electric vehicles, microgrid, DC grid, EV charging, conversion for so from these broad areas you can take project areas. Okay. But my suggestion is don't wait for your project. Finally, project in the final semester. So a BTech student can do n number of projects. Okay, 100 projects you do that. Who stops there? Is it right? So based on that, you will get better opportunities also. Next, you can do execute many type tests. These are all ways you can execute the project. These are steps generally we follow any solution, start with modeling, design, simulation, control optimization compared to development value. So tips, open access, mentor guide, all this. It is repeating slide. Yeah. So to become extraordinary, so you should experience out of box thinking for problem solution. Right? Say company or wherever, people will give problem to solve it. But you should showcase that out of box thinking. Maybe in some way you will come with a 100-line program, but other person has the same solution 10-line program, which is optimized. So he had out of box thinking. So like that, any job, you should showcase that out of box thinking. Then people will recognize you extraordinary. So this you will have. And 3 important learnings is one is continuous learning, morning also exercise. So without continuous, being a faculty or student or engineer anywhere. So if you are not having this continuous learning, then you are okay. And remember, now teachers are there to teach you. But after graduation, who will teach you? Nobody will teach you. You have to do everything. For which self-learning. Isn't it? Even project also. 99% you should expect. Be a mentor engineer. Isn't it? So now from onwards you have a habit to do the self-learning process. That's very much important in company also. So boss or team member, nobody will help you. So everything to self-learning process. And next is global learning. Whatever now learning, you try to adopt from global as well as you will implement in global also. Isn't it? With a BTech degree, you can get a job anywhere in the world. Global learning. That's what it is. And this power project. This is my startup company. So I have one startup. We launched the independent analytics. So that's the ethic connector. This is one startup. This is one example. Just I tell you. Suppose the coming end of money. So EV charges are there. Suppose EV charges, now look at this kind of thing. Is it right? Suppose this is system we want to design what is systematic arrangement. And similar one I will tell you is mobile charging. So you have adapters. So your adapter. Suppose you want to design an adapter. Then first step is you need to see that what is the relation between input and output. Okay. Input is AC, output is AC. You use it in rectification and finally use another rectification also. You have a closed loop control operation also. So this block diagram now we will connect to schematic. In schematic you will write each and detail in diagram. So now you choose that now why I choose 1 million inductor here, why this capacitor, why this company diode only, why only this microcontroller and why not other microcontroller like this. So you need to freeze your design. Okay, with the block diagram and then you come to the schematic diagram. Once you have schematic diagram, then you go to simulation. You go to simulation, then you study a simulation. And then see you getting a perfect output as per desired output. So then if you are not getting that results, then you have to go back to the previous design and rectify it and come back to final design. Then once the design is there, then schematic you take to PCB one. You have a PCB printed circuit board software on there. You take your schematic there and then completely do it there. And this is schematic. Then with my company name, I will try to patent it. Or you can calculate whatever design patent right, you will get it there. Then you can sell the work to the other company, other jobs. As individual also you can do that. So you can sell the work also. And finally you take the work and then proceed to PCB design. So this way you do the PCB design. And this is how you will be printed circuit. So print board will be circuited. You put holes on this. Then we show the components. Because the design is perfect. Then you place the components like this, optimize. And then finally this one we take it to testing. There are some testing agencies, they do as per standards, IEC standards, IEC standards, Bureau of Indian standards. So we send for this equipment for standards. They will see the compliance of it. If the equipment is compliant, they give a clearance, then they will give permission to sell the market. Then we will make a case, then release the market. So these are the So most of the equipment is a present, all electronic embedded systems, even including EVs. So if you have any startup idea, morning also I will discuss it in the recording. Okay? So anybody having idea, startup idea, or if anybody interested to make startup without idea. You don't have idea, but still you are interested. Yeah. What's your good name? So Rohini, Roshni. Okay. Others? Interested in startup. Okay. No worries. You don't have idea, but still you are interested. you please contact me. We'll mentoring. So we'll mentoring in startup. Okay, from the scratch, we'll take it to help you making registration and then business model, and we'll help you. And government also all faculty students they are allowed to make startup. Even BTech first year student, if your age is 18 plus, then you can make your own startup and you can incubate your company. So from college and then you can. This is my last slide. Opportunity types. Okay. First one, opportunity will come and knock your door. What you should do? What you should do? You should open the door and see that whether it's applicable, whether you want it. Then you should take a judgment. Is it right? But generally, what the students never open the door. They were sleeping. Sometimes students they get offer letter. Even our students they get offer letter, interview call. They will get emails. But a student never check the emails. Then loss. Like so, it may come in many ways. Opportunity. Don't think that it will come directly to email or phone call or text letter. Opportunity may come in any format. Okay. So like. And you need to search a long way and get the opportunity. Sometimes you need to spend a time, you need to travel also. Is it right? Then only you get the opportunity. And third one, sometimes call for opportunity, you need to come forward and then apply. Maybe job, any program. Is it right? That's your duty. Nobody will come to your home and give you offer letter without attending, without written test or anything. Is it right? So your duty should come forward and apply. And plenty of opportunities around you always, but those are invisible, but you should identify and grab them. You may think that I need some kind of faculty help from machine learning, artificial intelligence. But there are faculty in your own department, they are maybe working, who knows? Okay? But you should identify, even computer science faculty, they are there. So like that, there are around things will be there, but those are invisible. Nobody will keep a board that this is my expertise, my profile, and all in front of their board or door or something. Is it right? So you should identify and approach them. So that is your duty. And last one, sometimes call for first come first service based. Many times, bus tickets, train tickets, and guest house, maybe food, cinema hall. I think yesterday somebody movie released. So like my favorite movie is there. I will give a ticket. Houseful is still I will stand and see the movie. Whether you will get the ticket, first come first service based. So many opportunities also like first come first service based. So like this. Okay. So thank you. Any feedback from what you? Any feedback you want to come here and give?
If you have any doubts, you can ask. If you have any doubts, you can ask.
Anyone? Anyone? Not please.
Coming to the last session of the day 4, and here we are going to discuss about the reflection journal of what the research person has been discussed, and coming to the reflection journal. And these are the various machine learning techniques that are integrated for the electric vehicles, and in this journal we are going to discuss about the state of charge and state of health of the electric batteries, and how the electric batteries life can be improved by using the machine learning techniques, and how the charging phenomenon and the health phenomenon can be improved by applying the machine learning techniques for the electric vehicle. And in this one, so these are the different types of parameters, and these are the different types of the state of charging methods that are going to explain. And this one is the machine learning technique, and nothing but the neural networks and fuzzy logic method that are nothing but by using this artificial intelligence, the electric vehicle can be operated.
Here and from the Department of Electrical and Electronics Engineering, I would like to extend our heartfelt thanks to Dr. V Sandeep sir. Now, and also for spending valuable time for us, sir. Thank you very much, sir. Now I request our principal Dr. C. Nagabhaskar sir and head of the department and coordinator of ATAL FDP Dr. N. Samsivarav sir to please felicitate Dr. V Sandeep sir from NIT AP.
వీడియోలోని కొట్ట పైన వద్దన్నారా ఫోటో వద్దని చెప్పారా
అవి